We don't like. I don't think there's any difficulty here, is there? Nope. That's sort of a commitment. Worse. Absolutely massive coordinate systems. There we go, finally, east, north, up. Where do I want northeast down? Okay. View. So, wait, when do I this to render nicely. Picture appearance. Material 0 versus what's the default. And wait, what? Can it make up its mind what it's doing? Visibility, but texture mesh, what? Default. Is material 0 still a thing? Where you go? And material 0. I have no idea. Got no idea. Let's get rid of just here we go. No edges. But I still can see through it. Why are internal faces visible? I wonder what they're up to. Who's FLC 79? One resistance 79. Federal Aviation Administration. What are they up to? This is creepy. What are you? Somewhat reveals that it's not quite perfectly. I wish so much that I would be allowed to seriously modify, move bodies. Yes. Just have to do. Let's do this. Might as well just. Sure. Let's just have this. Out. This feels like more art than science. Hey, come here. Wrong. Wait, and Gerard just barfed. Dang it, I hope that wasn't important. What are they up to? Okay, that is offset. That's annoying. seriously. No. What? Now reverse engineer this curve. This is tough. Just did the best anchors. That just about gets it right there. It's a nice bit deeper. I don't know what column I'm going to do. Oh, this is so close. Very enticingly close, actually. Look at that. Oh man, so very, very close. Wish I could. Let's go straight for slash some more. proprietary and very difficult. Surface. I'm supposed to manually. Manual has to betray something. Okay. Aha! If only I could get a better close-up of that, and I think there is one. Let's take a look. I love Germany. Okay. Oh yes, there we go. That might help quite a bit. Thank you guys for showing me the solid model with edges. There we go. Okay. Right here. This tells me a lot looking at that. Still though, I wish I could just email them and ask them for this. It's not like they'd give it to me though. Sure, we'll send you proprietary information. Okay, that's probably all I'm going to get. So let's just take a quick catalog of everything that I've got. All of the images. We have an image of this, which doesn't do much, other than it's orthogonal. Orthogonal image of this. That's probably the best one yet. That image there, and this image here. So those two. This one shows a little bit of the front, but not enough. Well. And, you know what, I need to go wash this. I should probably consider the images I've captured good, and it's starting to crack. Let's go look at the selection. Okay, that's very complicated. That's the curve. So this is where do I have any view on if that is a curve all the way, or does it actually go straight? Everything's orthogonal here. Everything hides that. Is there any way to know what? It doesn't show me the bottom side of that either. This is probably the best view I'm going to get. Right there. There again. Is that straight, or is that a continuation of the curve? It's likely a continuation of the curve, Steve. Talking to myself, and that's not weird. Okay. Okay. Let's lay down the first dimension. 10. Is that a blob or is that? It's hard to tell. 16 flat. 17 big beautiful, but it's not like it's lower. And slightly. Okay. I'm getting neurotic with the 5 and I'll sketch it half the millimeter. This minor feature that wasn't picked up. what I'm gonna do, I need to go wash this thing off. I need to look at the inside again and get some hints as to how this thing's designed. That's not telling me enough. Let's move this before I have to spell it anymore. Should be fair. So curious. I'm gonna regret this. Let's just do this. This is the lip. Let's focus on that lip there. That. Okay. So what it is, there's that lip. And then they added that draft sort to it. That, I think I can replicate that. I think, just have to, and it's that would really be handy if it were on that plane there. If that plane could be the interface is, oh, blast, you know, there's a slight distinction. Is there? See if I can get an angle measure on that. Just, oh, all this time. I'm sorry, I didn't have the camera looking. There we go, I might as well go with full webcam. Okay. I'm obsessing over angles. Does it matter? Does it matter? Okay. So that's what I want to do. That's the original carve that they did. They did that as the original carve. That was the original. And then they did that. Do I know if this is a perfect circle? If that's a perfect circle, that's a great starting point. That would be an amazing starting point, is to know that profile. And then to know what they... It's almost time for me to image the sailplane itself, actually. If I were to be obsessed enough to dot every single Bernoulli cell on this, and then to try to image, and then that would allow me to build up the cross section they used. Or I could make a guess. But blast, this is turning into a much more complicated and longer project than it needs to be. Well, again, as I did in stream 6, and I brought up Notepad++ and put out, or laid out the things I need to do. Okay, I'm going to attempt this task. shouldn't attempt this if I can't complete this. So I want to have a curve that follows. Wait, let's do this again. Yeah, so what would be exposed is this. Yeah, okay. So I have to follow this edge, not that edge, but I have to follow this edge. Ignore. Okay, so basically the brown edge. I want to go after the brown edge. And then I do need to understand, if that was that cut out. What is this? Why? Why? What is that? Is it inherited off of? What is that displaced as? If that were just a offset of the surface, is that consistent? Can I prove that that is basically that curve displaced down slightly? Can I prove that? How can I prove that? I have the model right there, but I can't measure it. I can try it in MeshLab, but MeshLab only does lengths. It doesn't do X, Y, and Z displacement, and even if it does, I don't feel like digging around to find out. And I did it again, where I'm not properly, whatever. Those are probably, it's probably the safest view is to just keep it in that view. So that's how they did that. They displaced it down. Displacement down. Volume. How did they do that? How would you do this if you were designing this? I'd cut the canopy like that. That's the canopy. Ceiling line right there. And then take the canopy model and I would select that and try again. So let's just go point to point. Hey, this is getting somewhere. That looks very close. No idea what's my intention the designer used. I guess. I don't even know how the designer cut this. What if it was just a bunch of piecewise? That's close, but that doesn't follow the brown line. Let's try this with arcs. So that's close. Is it one continuous cut? By the way, I really need to get out of this mode. I'm doing rail lines now, kindly making real. The things you can approximate with circles. Here. That's very close. Oh, and did I didn't. It's very close. The problem is, this would have appeared in the solid model. So I go back to this. Any kind of a piecewise circle. A piecewise circle would have had divots appear wherever there's a tangency. I bet they did this in SolidWorks or CATIA, but I think that all the three modeling software basically follows the same rule. After all, like here, I can prove that. I'm pretty sure that this wing you'd want to have a tangent to 90 degrees. That should be a tangential surface, smooth. And there's a seam there. There's also a seam for the fuselage itself, though they did partition it as well. I need to find somewhere to prove the fillets. Anywhere there's a fillet, fillets are supposed to be smooth transitions from one surface to another, and it has a seam there. Therefore, I can prove that it's not a piecewise circle, it's actually a spline. Okay. So I have to delete those, even though they work. By the way, can I please change visibility? Thank you. Okay. So I can't use circles, it has to be a spline. So I have to figure out what the control points are for the spline. What can I do for the control points? I want to do as few as possible. So just starting with one. Create. Okay. So that looks really good right there. What's your point? I wish I could. No, let's go to spline tension. More than two control points, and it's going to become one big hairy mess. Spline tension. I can't exactly control the equation, can I? Actually, wait, I can. The equation fit method. AutoCAD standard management energy. If they did that in CATIA or SolidWorks or something, they're not going to be doing an AutoCAD algorithm. It's either standard or minimum energy. Let's try minimum energy and see what happens. Is there some kind of an auto? If I could find a method that would auto spline or detect the closest spline. You know what you're doing though is you're having the exit point there. What if the exit point is higher up? I could force it. I could force it to go here. It's basically right on the edge. Back to the fitting method. Wait. Under minimum energy, there still isn't spline tension. There's too many variables here. It's standard airplane. American Airlines. Who are you? You are a airplane flying out of 8910 Victor. Five, nine, wait, I one. 5901 Victor Piper, and say, who are you? How do you get to go flying in the middle of the day? It was a pandemic, so. And there's creepy FAA doing their thing again. What the heck are they doing? What the heck is that airplane doing? What was that big jet doing? 777. 777-300, if that's what that renders us. And there's creepy FAA. Sometimes that's FLC. I wonder if that's some kind of a checkout, but normally flight schools. You know, super distracted. Okay, add another point. Now I'm going to break something, or I get it to work just fine. Let's take a look at the actual artifact here. Yeah, it does have to. This is it. Not rendering the way I want it to. Just like what happened yesterday with trying to model the servo. I'm basically getting fatigue here. I'm basically looking at what I have to do, and I'm trying to estimate, is it really worth it? Is it really worth trying to capture Canopy? One part of my head screams yes, otherwise why would I have attempted this for the entire past weekend? The other half of me is like, forget this. It's time to go do more important things. So, indeed, at least I can come back to this later. Let's save this, and let's put it in the main library in the huge pile of just about everything else that I have. And we're going to call this Canopy. Now, I wonder if it's going to save that as part of it. Anyhow, let's transition. So, as I put in the title or anthem of our live stream here, I've got a few other things to do today, so let's get to those. And I'm going to, for the first time in my live streams, I'm actually going to leave it unattended while I go to get lunch or wash off the canopy or whatnot. Do I really want to wash this thing off? I think that's a way for me to commit to what I've already got for my captures. I don't need to get another one. This one is probably as good as I'm going to get for the amount of effort I've put in. So let's close that. Though, I am up for reopening go find Fox here. FGH. Come on, Fox. Fox here, toothless. So I'm going to leave that up though. So if I feel like things this, let's go back to our schematic harness and diagram. And so I need to construct is this connector. I decided to make the VTX connectors pluggable, or hot pluggable would be the term. There's no way I'm going to accidentally fry if I have one plug into the other. I might as well just make it such. Those need to go to some kind of a board. So this board needs to be constructed. I have this pigtail. I need to decide. I think I'm going to have that go direct to board as well. I think this is all still valid. I do need to video input. Oh, I missed that. This guy, toothless, has to go directly to the man mostly. I just found a mistake. Or, let's put you up here. What are you doing? Go away. I just want to grab you. Let's see. Yeah. So, some arbitrary voltage. Still hear airplanes. That must be what I hear right now. Who leads that? There. Okay. No connection there. Extension goes here. And that goes into the primary, secondary, and third. Really, let me push this around. Yeah. Okay, good. I am doing webcam only. Or not webcam, display only. Okay, so plus 12 volts. Plus 12 volts to everything. Too much. Audio input. Audio input, I need to figure out where the mic's going to go with this. And all this needs to be moved and pushed at some point. Yeah, and that's also not. Let's just, there we go. OSD. It's important that the OSD only is exposed to a single camera, because this is older and it can't do the NTSC L switch, and it will probably get you upset. And if the OSD is going to go crazy, I don't want to have it intercepting all of the cameras. What have I done? I wasn't paying attention there. Oh, the tail. Okay. That was a mistake. Look at this guy here. Here and this VCC on the VMAX doesn't have to be used. I don't have to have a VideoMax having any 12 volts on it. That is, if this is going to be a custom harness on the board. So I have to decide what the partition is. What is the distinction? Or do I use the VideoMax for something purpose and keep wiring just to as minimal patch cabling as possible. That would make it more adaptable in the future. Here's another airplane. Something that isn't Cape Air. 595 Cape Mike. Sounds like a twin. Cape Mike, there we go. And so it's not Cape Mike. GR30 is probably a faster airplane. It is a Beechcraft C90. Milesboro Aviation of Kennebec, Maine. Okay. It's only 3,000 feet. It's pretty low. Maybe they're landing. That's what's going on. So let's do the naive presentation, which is to say, okay, so these are the harnesses coming from the wing that have to have special treatment, but otherwise everything else would be a direct patch cable. So I would have this. Let's actually pull you inside. No, what am I doing? There. So that's going to be turned into a nice, well-behaved 3-lead patch cord. So ground video out. Consoles. So I can leave this patch cord. Indicate it's a standard patch. I'm just asking for ground loops. on for the naive implementation, which is what's the audio going to look like for the mic? It's going to be a 3 or 4 wire there. So 3 wires. I'm going to do 4 wire. What's the sheet was? For curiosity, how pliable is this USB cable that I got? Is it more pliable than the... No, it's still... Comparing it to the security wire, well, it is a lot more pliable. It's generally more pliable, but still for the area. somewhat confusing by having that. Hey, come here. Uh-oh. Okay, the stream's still going. No, wait, what am I doing? The Distribution Amplifier is ultimately is grab this. Okay. Thank you for saying that. use 5 volts anymore, do I? Thankfully, yeah, mind you, selection. Let's choose up to 36 volts for the one now. Oh yeah, that's exactly where I got stuck last time when I was making that order. On that note, let's go find that order. Okay, here's an LT. Let's go back. You're an LM7171. Right here. So make up your mind. What's your specifications? It's basically 12 volts. Uh-oh. Dang it. Have I made another error? What's V in minus lowest relative to the... Dang it, have I just made another mistake? Do I have to float the video symbol somehow? Place be rail to rail. What was the digigantry for this? Was this advertised as rail to rail? Oh, nuts. I just can't get a break, can I? I've ordered 2 different chips. And I am now at the mercy of this data sheet to find out if I have made a mistake or not. Please tell me that I can do this single-sided. Please tell me. Oh, this is not looking good. Nuts. I hate you guys. Why? Hey, I'm mad at myself. Plus. Electrical. Electrical 16 AC versus DC. Okay. Let's just go down to there's a big inline driver right there. It's no mention. Let me make this reference to ground there. Mm-hmm. Gosh. I've blown it, haven't I? Okay. I'm getting too excited. Let's just work the problem. Let's work this and see what is the lowest VS can be in relationship to the negative input. So Vn minus, and well, Vn plus. Let's go back to the implementation of this with a gain. Is that not inverting? Yeah, that's non-inverting. That is a non-inverting setup. So that would be 1.1-ish volts. I could do. Could I put a capacitor in line with that? That would remove. Do exactly. I don't think it can capacitor. You can't do that at the line level. Like it's ultimately going to a video transmitter on the airplane anyway, which is ultimately just turning things through, which I have to be desensitized. Okay, let's go right back. I'm dancing around with the issue. Let's go find this. Some maximum ratings. I don't care about plus or minus 15. I want to find plus or minus 5, which is closest to 12. What does that mean exactly? No volts. Okay. Common mode voltage range. So common mode. I guess I'm gonna have to build this and find out if it works. Am I forgetting about how op amps work? I'm not, because as far as the V minus and V plus thing, if I give it what is referenced to ground is V minus and plus 12 volts is V plus, that basically means I'm driving it with negative 6 volts to positive 6 volts. So if I'm giving it negative 6 volts to positive 6 volts, yeah, the common mode voltage thing is going to bite me. Because what I'm essentially doing is I'm giving it a negative 6 volts to negative 5 volts range signal on the input. On which input? Because you're differentially. Well, yeah, it's going to be, because the negative pin is grounded, the positive pin is going to, equivalence principle, it's going to try to get to the positive pin and negative pin to match. That's the whole point of an op-amp. So, if we look at our circuit here, if this is pretty much positive 6 volts, or it thinks, no, because you're giving that negative 6 volts, essentially. So if that's, as far as this amplifier is concerned, that's negative 6 volts, and this is between negative 6 volts and negative 5 volts. But ground, wait, so let's say ground here, you're not voltage dividing 12 volts. You're not making a voltage divider to make 6 volts as a reference to ground, are you? If I were to do that, then this signal would indeed be negative 6 to negative 5 if I had a voltage divider creating this here, creating what is actually positive 6 volts for ground to positive 12. So that means this is basically going to be dancing here. Okay, let's try this again. 7171. Let's go to the DigiKey entry for this. What does it say? Output type. It doesn't say rail to rail. Look, there we go. There's single-ended. What? Oh, plus or minus. And then 5.5 to 36. Wait, what? Someone mistyped that in the datasheet because that was... Now I can't even read datasheets. Okay. Back we go to the top. How the heck do I work this thing? What the heck am I doing here? Specified for plus or minus 15 volt operation and plus or minus 5 volt operation. Someone miskeyed the datasheet because unless they're going to the maximum ratings section, which says 36 volts. Aha, 5.5 volts supply voltage to 36 volts. V plus to V minus. Okay, 5.5. So maybe the DigiKey archivist is correct. Input voltage. Every so often you have to go back to the basics. I'm going to have to basically breadboard this thing, hit it with 12 volts, and see what happens as I give it a varying input from 0 volts to 5-ish volts or something. What's that circuit? Well, I can probably do that right now. It's I don't have my laboratory power supply out. Let's take the closing tools. Let's do some quick and dirty prototyping. So, let's go find a breadboard. is fair game. Okay. I feel like I have 20 breadboards running around here though. Okay, this was a bunch of diodes to try to dissipate a bunch of heat or something off of 12 volts. I don't remember what it was, and now it's disassembled. Let's put these back in to the kit. Okay, the 12 volt source for today, I'm going to set it from one of the batteries. I'm going to go here. 11.2 is fair. And let's just make sure the cells are balanced, which they are. Okay, so there's that. Well, let's make sure this goes away. Now I have one on the board ready to go. Let's take this one and let's push it down. And let's give you, there we go. So it's indexed on pin 11. I need to figure out harnessing. How am I going to connect that? What I really need is really have that. Hey, check it out. I have this guy, but it's not right. What is this? That's not right either. Oh yeah, check that out. I'll totally take that if I can avoid ripping it apart. See this? And there's no battery connected. I'm not going to suddenly... Of course, when I have sharp things, I get phobic and I have to put on my glasses. Okay. There we go. Without snapping the hobby knife blade. I like Dean's connectors. I'm sad the company is basically doomed with the XT60 invasion. So this will be a very nice and snazzy, correctly polarized. Okay. Let's make sure I don't put 12 volts on any of those rails. I only want to put 12 volts on for this project only. There we go. What's the temperature outside? I'm so tempted to open the window. 48 degrees, according to that, 49 degrees, according to that, and 48 degrees. It's only risen about 8 degrees this whole day. I'll keep the windows closed for now, but there's a beautiful spring day of sounds out there. Okay, so that's going to connect in, and that will connect to here. And how does that conduct? Is this happy? Yeah, there we go. Okay, so let's construct that circuit that it told us about. Snipping wise, yeah, I think I saved that, so I can totally, I'm just going to use the snipping tool just to capture this thing because I'm too lazy to open two PDFs simultaneously. So I'm just going to put that on the other screen. By the way, how's the stream going? No dock packets, 2 hours in. Looks like it's good. And let's go view. I don't have any chat messages. Stream's still up according to Google/YouTube. Cool. So now let's go down to the circuit that I want to build. And feeling stressed for time, I really should have just... Let's see this. So we have different sets of resistors here. Don't want you. I want this. Capacitors. There we go. 75 ohms. And I purchased this for the other amp, which wanted 410 or 402 ohms. I'm hoping 402 versus, oh, dang it. Come on, what are you? Okay, where was I? Yeah, 402 versus 510. I hope that will be alright to deviate. Really, it's just going to violate flatness, I'm sure, that's all it's going to do. Okay, so video window. Yeah, okay, I have this well formed. I guess for some minor history, that is an ATmega 328P, just with a crystal, as minimal as you can get for programming microcontrollers. This is the scuba diving watch circuit, and I probably should pull off from the last dives I did on the cruise I went in January. I think I may have already done that. One of these days, anyhow. This is coming out of the bag. This is 402. I can't stand, okay, let's verify. 402, which would be yellow, black, red, and then you have the other bands, which are just super confusing. And if that's 75, purple is 7, green is 5, 0. Okay. 402. And how many of these do we want? We only need 2 of them. And lazy me, I'm just going to trim. I'm going to just trim that. And for 75, let's see, I can probably just get away with 1 75 output for now, and I can put that as a 75 out to ground. What am I doing there? It's actually 150 if I just dump it to ground directly. Or does it really even matter? The output of the op amp, it doesn't matter what I do with the output. The only reason to have any kind of loading resistor on the output is if it has to be stable, if there has to be some minimum load. And otherwise, I'm not going to worry about that. So you are definitely 75, purple green, okay. And does it even matter having a 75 to ground? Okay, really, I'm just doing a non-inverting. All that really matters is the 402 resistors. That's all that really matters in this test today. I should pull out the benchtop power supply. I have it in its box. I packed it up over a month ago with the coronavirus pandemic scare and the depths of uncertainty. Now that things have cooled down, I still haven't fully unpacked into my lab. Let's see. So purple, green is 75, 75 to ground for the positive lead, and now I have to pull that up. Positive lead is pin 3. Okay. So pin 3. Just gonna do that. That should do. Wait, what am I doing? 75 goes to ground. Okay, so I can ground that. Let's just do that. Wait a second, I have 2 75s. I might as well do the full simulation. Okay, so let's get another one out. So, you know what? Let's actually move power to here, and that can go to as well. Okay. And let's make an input signal of, I'll do that right there. Okay, now for the 4 yellow. Okay. So that's going to be negative to ground and negative to output. So negative is pin 2. I'm not going to do this without having it short out. So 2, negative 2 ground. Okay, and if I form that correctly, even if they can't bang into each other now if I keep that going like that. There we go. So form to, yeah, pin to negative input to ground. And then output, so 2 to 6. If I have that reach around like that there, that somewhat prevents, and then I'll just bend that slightly. There we go. I like to live dangerously. Yeah, that should do. Okay. To the output, V plus is 7. So let's take a spare katana MPPT. Let's set it right there. By the way, how well have I formed? Let's push the camera a little bit closer. There we go. Don't die, camera. Don't die. Okay. So what to pull? Pin 7 gets to have that. That fits perfectly sweet. Okay. Sticking on positive. So again, pin 7 is 4 gets ground. So let's find a black and form that. And here we go. Gotcha. Formed ground. Okay, in terms of adding a capacitor, I'll just add some kind of bulk capacitance plus a closer in. I can use one of these. So there's a 1 microfarad, 0.1. Let's use one of the 1 micros, of which I got 4, just 4. I guess they were fairly expensive. Oh, I guess you are the chosen one. Let's put you without having you short. Maybe minus. That's too close to shorting. As much as I like to live dangerously, there's no reason for me to actually have something explode. Let's go through my regular kit. Let's go through here. I don't know why I have your plugs in here. There's extra heat shrink tubing that should be donated there. There we go. You guys say 104, which is probably 0.1 microfarad. But you know what? I think you'll do, unless I have any others. Oh, I'll take blue if you guys are 105. What are you? 102, that's tiny. I want something a little bit bigger. 104, that'll do. And can I have you jump across there without? And what's the chances you're going to bang into that? I don't want you to do that. That'll do for bypass capacitance. So I formed the circuit. I don't really care much about the output. I should have the oscilloscope here. It's time to get the oscilloscope out. It's oscilloscope season. And to make a varying input voltage, I need the laboratory power supply too. ground. So what's not connected is 1, 8, and 5, which is correct. Okay, oh, the final thing is let's connect the input. Well, oh wait, that's already solved. I already have 75 to ground and 75 from the input. Okay. And the output I'll just grab with the oscilloscope. So yeah, this is ready to go. You know, I don't have to have the oscilloscope. If this is all completely DC, if I'm doing completely DC land, then I could, ooh, yeah, I want to have that spark. I just need a way to have a arbitrary input voltage, which means I could put in a potentiometer. Potentiometer would present a, at that point everything is a short, or the resistances don't matter on the input. Other than that, it's a voltage divider. I did incorrectly. I looked at the 75 ohm cable thinking I had to do that, but I really don't. I don't need to have, unless I want to simulate the I don't need that. No. You know what, just get rid of both of the 75 ohms. And I'm just going to do this. We're just going to take a potentiometer, and I will try to, what are you? You are a 102, which is that 1K, that's 10 times 10 to the second power, so that's 10 to the, that should be 1K. 102 is 1K, right? Because 101 would be 100, and 100 is just 10, right? Yeah, that is 1K. So if I have a 1K input, that should be fair. Am I going to do this? So we have a 1K resistor. Where did I put the off? Did I recycle that back in? So I've got a driver here. Okay. So if I give, that pin goes to ground. By the way, I want to go sideways. There we go, like that. And it'd probably make more sense just to do this. Okay. This one's expired. That one needs to be fixed. Also, more heat shrink. Yay. I think all of the heat shrink I'm going to be taking out of here. All the heat shrink should just be consolidated to the new spot right next to the soldering station. Which I might regret this later on if I am in a desperate heat sink shortage and I don't have any, secret caches of heat shrink like the little spot I have here. But sorry, future me. Hopefully I can prevent that from happening by always maintaining a good amount of heat shrink. So let's use longer. Actually, that's too frail. Let's just use this. So I'm going to use this. And I'll bend that and adjust. And there we go. That's our ground. And then I can use, I don't know, let's think. If I'm giving it 12 volts, a 10K resistor would do great for chopping down. It would actually make the total is 11. So it'd basically be an 11 ohm potentiometer with the wand only sweeping from 0 to 1K position. So potentiometer, I have to do the math in my head. That's over the total 1K divided by 11. that would only get you to about 1 volt about, because you're dealing with 12 volts or 11 volts, which 11, So if I can find a 10K, which, are you guys 10K? I can never tell when you have the extra double stripe. It's orange. It's either 10K or 100K. You are 1374. Oh, you are 100K. Okay. So I want to double stripe with red, not orange. Or such a mess. There's 400s. I need something that's traditional. What are you? I find one that isn't following the traditional. By the way, what are you guys rated at? 50 volts, 100 microamps? Oh, that's nice. Or 100 microfarad. You are probably an inductor, actually. Oh, look at that. That's 1K. So that's a super precision 1K. And I want... There's another 1K. I want a 10K. Can I just find a 10K in here somewhere? Do I have one running around? I could steal. I could do shameless stealing from the scuba diving circuit, but then I'll never reconstruct it. I can't steal from that. I know I have these. I have lots of... There's another one. Or is it the same one I measured? Okay. Aha. You are what I want. That is a non-double striped with orange on it. So black, brown, orange should put you in the 10K region. Voila, 10K. So we're going to feed 10K to the top of the potentiometer. There we go. Okay, and then finally, the signal that I'm generating. See, I didn't have to get out the oscilloscope. No, I have to get out the oscilloscope and unpack. Let's go with that yellow one right there. That one looks perfect. So the input, again, input is pin 3, which is positive, and this is not inverting amplifier. Okay. So input, and so the Thevenin equivalent impedance on the input here is going to be on the order of about 1K. So I hope the amplifier circuitry doesn't mind. I'm not doing any AC waveforms, it's all DC, so it shouldn't matter. Okay, and I'm going to trust that this potentiometer is trustworthy. Let's go to voltage. So I'll be able to measure the voltage. Let's make my life easier by finding the appropriate lead. There we go. So let's swap out the black lead for the alligator clip black lead. And that makes my life a lot easier. And let's find something that doesn't mind becoming... it's too risky. I can't do that. What if I... Okay, I have to find a single wire. Let's just go yellow. Yellow isn't black, but there we go. That will serve as our ground reference. Okay. So now let's just go over the circuit just to be sure I'm doing this correctly. So this is a LM7171. Verify datasheet says LM7171. Yep. Okay. So looking at that, not connected is 1, 8, and 5. So 1, 8, and 5 don't have connections. Negative input is 2, which according to that circuit should be 400 ohms-ish to ground. So 2, it's 400 ohms-ish. Yep. To ground. And I'm moving dangerously there. As long as I don't accidentally wipe the circuit, I'll be safe. Okay. And then the next one is pin 3. Pin 3 is positive, and it gets... or it did have the 75 ohm cable and 75 ohm resistor to ground, but instead the pin 3 only goes to the potentiometer, which potentiometer, you have large 10K, 1K potentiometer to ground, okay, and I have it turned up to about a 0.5 volt right now, or something like that. And then ground is pin 4, V minus, okay, and that goes to ground. I have a minimal amount of decoupling with a capacitor there, and then pin 7. Pin 7 gets only that. That's the only place. This is definitely correctly formed. Correctly formed. Correctly formed. I've got this guy going. Okay, and so finally the output is what I want to measure. So I'm going to be taking this red wire and I'm going to be poking the output without touching anything else. I'm going to be switching between that and the input. Here we go. This is our test to see how the LM7171 behaves for what I'm going to be subjecting it to. And if I really want to study the AC behavior, I can do that later. So let's verify. And there we go. That should barely be visible on the screen. Is that visible on the screen? Yeah, that should be visible. So that shows 11 volts. The potentiometer is at 1 volt at that point in the bridge, and I'm lazy. Let's just do this. I'm just going to poke a resistor in there, and I'm going to poke the junction to that. So that's 0.5 volts. And the output, please be well behaved, is on the handful of millivolts. Oh no. This is not going to be good. So if I raise that, it's in a configuration of 2x, right? It should be, so that says 0.8 for an input of 9. Okay, I've forgotten how to do non-inverting op-amp. When you have the two resistors equal, that's a gain of 2, gain of positive 2, right? Which means if the input is 0.5, the output should be 1. Right? Okay, I'm in trouble. Okay, 11. Let's just verify that's smooth. And in there. Oh, serious, I bet. Short attention span multimeter. Okay. Let's go to 500 millivolts. So 500 millivolts, the output is 50 millivolts. By the way, let's give it an actual load. So this was 75 ohms to ground. If I give it an actual load, this is very hazardous. I don't have a very good ground running around that I can poke to, so let's just make a new one. In fact, I've completely filled it up, so let's go and make a new branch. And I'm just going to creep around to here. There we go. Oh, and it's not very enthusiastic about it. It should be showing 11. Okay, good. And give our output here something I can enthusiastically drive through a 75 ohm resistor to ground, which doesn't matter because it's not very far away from ground anyway. It's only on the millivolts. So that really isn't going to do much, but I just have to explore the possibility just to be sure. Yeah, that's 5 millivolts. And if I turn that up, so now if this is outputting 1 almost exactly volts, referenced to ground, which is also ground being the V minus input. I shot myself in the foot without a rail to rail. I should have just gotten a traditional up amp. Yeah. Okay. So now what? Well, let's disconnect this and let's try the voltage divider option. This is not good. As I understand the video signal, hold on a second. We know okay, I measured this. If the final downstream is AC coupled, then it doesn't matter what I do upstream then, right? So the VTX, I measured this, it's 71 ohms to ground for video input. Yeah. So 71 ohms to ground. I don't think that can be AC coupled, can it? Can't AC couple video, can you? You know, the video distribution amplifier board was a good idea, but the simple or the naive approach would be to completely delete this. At least I'll move it out of the way for now. The completely naive approach is to basically take the output here and to basically split it. And that is to completely naively split it with no regards to signal integrity. So I'd split it here and I'd have it split to the video input here. So doing this is a big no-no in signal integrity. You're not supposed to do this. You're supposed to have an amplifier that drives both. What I will do, if I really want to do this correctly, is I have to tear apart the Video Max, which is a little Hobby King tiny thing, and I'd have to basically build or tack on a 75 ohm resistor before the other 75 ohm resistor. I'd basically do exactly what's doing here. It's likely that if I did do that, yeah, I'd basically, what I'm doing, you don't want to have a multiple connection on this side of it. You want to have the 75, yeah, you want to have this side of, and a new 75 ohm. So you'd have one 75 ohm and then another 75 ohm to your split. And then we're just going to rely on the amplifier inside the Video Max being able to drive both. Yeah, signal integrity, you're not supposed to do that. And I can do a quick demonstration of why you don't do that. So let's take out Falstad and let's go to our classic transmission circuits, and I want to do just a, let's study termination. So let's make sure that I'm not cutting anything off here. Okay, yeah, let's just go to webcam only. So we want to study what happens when you have one transmission cable. Can I copy? I can. And then I can paste, Control V, there we go. Actually, never mind, I want to do this. I want to just copy this. So this is what it's supposed to look like. And this is what happens when you are a naughty engineer and you decide to copy, paste. So I'm going to have that go there, and that go there, and then this probably made it. Okay. You're not supposed to be able to do that. Okay. Yeah, you can see the signal level is lower. if I were to plot, so first of all, let's look at the ground truth, what it's supposed to look like, view and scope, and view and scope. And I want to go to max scale, max scale. So the scale will somewhat lie, except look carefully. That's 1.67 volts right there versus a max of 2.5, or it tells us there in the corner with a hint. So I haven't halved it. I've chopped it down slightly to a third. 2/3? What is that? Yeah, that's 2/3 because 5. 2.5 goes to 5, so that's 3.3. Yeah, I think that's 2/3. So, and if I just remove that, actually, can I combine the plots? I should be able to combine. So you can see one of them is lower, and that is not something we want to do with the video system. The video system, it has to have the signal be that, and you see, this is, so I have some mystery still going on in my head. I need to understand on that video receiver, or I mean the video transmitter, it has, let's just make another one. Yeah, let's make a blank circuit. So they basically have our 75 ohm to ground. And I'm going to make a wire. So it has an input. What I don't know is on the internals of that, does it go to a capacitor or is it going directly? So the other option, the other possibility is it goes directly to a piece of silicon that needs to have that level at a certain point. Or, yeah, it goes into, let's go find chips, different kinds of chips here. So very lightweight active building blocks, components. Let's just pretend it goes into, where's an op amp? I forgot where op amps lived. There we go. Yeah, let's just pretend it goes to an op amp or something, and it has to be, all I know, I wasn't tearing that apart. I could tear it apart and I could look and see. That doesn't matter. If it's capacitively coupled, there's no, again, this is just something I could quickly experiment with and find out. Why not just split the video signal and see what happens? Let's go to the definition of CVBS. Fine, let's just go to CVBS, which is composite video broadcast signal, and it tells us the electrical components of this, right? Yeah, and this is where you have to have it be, yeah, this is important. You can't AC couple this. And you can't attenuate this. You shouldn't be attenuating this. Now, there's one major assumption. How do I know that the video, well, yeah, it was 75 ohms down. It was pulling it down 75 ohms for sure on the video transmitter. Did I measure? I haven't measured it for the one in the tail, but I'm fairly certain it's also going to be 75 ohm terminated. Now, to demonstrate what I was saying earlier, if I do that, now I have nice happy signals that are correctly formatted. I'm not having to attenuate by 2/3 by circumventing the 75 ohm output. There lies a question then. Are they, because according to, a proper correct implementation would have a 75 ohm output, but how do I know that these guys, you made the Hobby King video mix, how do I know what that is? What is their output? How would I measure an output? Well, I could do the open circuit voltage short circuit current method. How do you short circuit and measure that short circuit current? And would I be hurting anything? I could do it very briefly, very momentarily, and I probably wouldn't overheat something. Open circuit voltage, short circuit current. Let's do that. So yeah, Hobby King. Let's do this. So let's just pause, run stop, because I don't want my computer to be burning unnecessary calories. And let's go back to webcam. And I could even just do webcam only. Okay. So here's our typical Hobby King 3-channel switcher. It says to receiver. And I don't know what the behavior of this thing is when it's not receiving anything. Use that. Okay. So what we're gonna do, plug that in, and plug this guy in to receiver, and let's just get the other one out. Right. Otherwise, that one tapes down. Now I'm assuming that this works correctly. I do have 2 examples of it, so if I have to use the other one, let's be absolutely positively sure. Negative, positive to receiver, signal, okay, to receiver. 2 examples of it there, okay. And then the output video there. So I'm going to be shorting. So I've, hey, nice. That's exactly what I needed. That is exactly the cable I needed. Okay, output video. I know for certain, having measured the Hobby King video switcher before, that the I don't even know if, let's verify, is the ground, does it isolate the ground? It couldn't do that. They couldn't isolate the ground because you'd have the ground from the RC receiver system. If that wasn't truly associated with the ground in the video system, then your video signal would, because it's associated with that, the video signal would go all over the place. Let's do this. So let's put you here. Just gonna find 2 positions there. And actually, let's spread that far enough apart that I could totally take that 75 ohm load, just as the initial load I'm going to give it is 75, and then I'm going to try shorting it later on. But I don't have to. I could determine what the intrinsic resistance is on its output driver, if there is an inline intrinsic resistance. Okay, camera 1, camera 2, camera 3, output video signal is red, brown is ground. So first of all, let's determine what is the grounding scheme. This better chime. There we go, it is. So all the grounds are the same. So that's important to establish. Now, I wonder what the output video does when there is no input video signal. They're basically floating. There's nothing touching them. So, okay, verify. Red is red, black is black. That can connect. Already verified, that's good. That is not touching anything on that row. That is good. And let's go find, is it down? Okay. I'm just gonna stick, as I did earlier, I'm just gonna have something sticking out since I'm gonna use that 75 ohm resistor anyway. Okay, so that, I don't want to do that. I'm gonna measure voltage now. Okay, and then I'll be able to measure current directly through this as well, using the multimeter. So right now that's floating. This is what a floating multimeter looks like, making sure it's in the video feed so we can see that. Okay. And it's blue. Okay. So I don't really care which camera input it's selecting from. I don't know what the start behavior is, but I do know it's got to be pushing an output of some kind. There's no way it could. They're not going to make it fancy enough where it detects a high input impedance and therefore deduce there's not a camera connected. It's a dumb circuit. It's just an amplifier multiplexer. So according to this, That looks like it's floating. It must be capacitively coupled, knowing that multimeters tend to drift up and down a little bit like that when you have the capacitor. So it could be capacitively coupled on the output. Again, I highly doubt it though, especially for video signal. I don't think you can do that. You can't capacitively couple video signal. Not especially if there's a 75 ohm. I don't know what I'm doing. Okay. So let's just verify. Yeah, that's totally in the 200 something millivolt range. Now, yeah, okay, I probably should. I'm going to guess that it startup behavior is probably going to be camera 1. So with camera 1, what happens if I press my finger? Aha, check that out. And that's just camera 1. Let's verify. Let's let that drift up again. Let's make sure. Okay, so the new normal for it is 77-ish. So now if I touch another one, that does do some, that is doing something. Do I have to give this a real receiver signal? I think I have to give it a real receiver signal, don't I? That's camera 3. And what happens if I just touch using my finger, camera 2? But number 1 definitely. Okay. This is getting more complicated, and the afternoon wanes on. There are so many other things, such as finishing the harness, and 3D modeling this guy, and doing the microphone here. So I can definitely 3D model this guy, or at least capture the footage for him. I can, let's look outside. It's sunny, there's direct sunlight. If it would be indirect, cloudy, overcast, that would be perfect for taking it outside and taking imagery. Or I can just do the same setup I've had in here with that. But let's figure out what's the next thing I can do here. I can't measure open circuit voltage, short circuit current until I have a known output. And I know it's going to be 1-to-1. It has a gain of 1. It has to be. It's a multiplexer. It has to replicate the input signal, output signal relationship perfectly. So how do I make 1 volt on that? How do I even know what the input limits on that thing are? It's Hobby King. I don't think it's going to say, by the way, the inputs are rated for this many volts, blah, blah, blah. Why the heck am I even using a Hobby King video switcher in the first place? Because I can. And, you know, I guess that is a good question. But I'm over-engineering this project enough as it is. It's a cost solution. I shouldn't overanalyze it. So let's get the receiver out. Here's our receiver, and I'm going to have to turn on the radio for this too. Okay. That's FR Sky Sim. I want to go to, let's do here in raw. So here in raw, that there, I want to go to, oh, is there another? I need to go to a profile that actually has a usable Minihawk 1. Did I have that as a 3-position switch? Do I have a 3-position? Yes, I do. So, channel 5. Let's leave that up there. Channel 5 is open. And let's use the patch. Let's take these off. So I'm going to use this really nifty patch that is male on both ends, or a female. I can never tell the difference with plugs because it's really holes and sockets. So it's just like, what? Negative. Okay. Absolutely positively sure. Ground, positive signal, white wire. 5. Okay. And just to be certain, let's get a servo out. I should have the servos running around, running them up. There we go. And this is probably a 360 modified. Let's get a regular 360 servo. Actually, let's test this little guy. This guy. Alrighty. so I can totally hot plug this. There we go. Aha! This was the pan servo on the original Cali. I've intercepted the potentiometers inside and scaled them so that way I can look left and right. Okay, so that verifies it works. So I've proven that I have good PWM output. So now, going right off of that, let's take you, disconnect that, and signal positive and minus. Let's do this. Somewhat risky to do it while everything is hot and alive, but there we go. It's happy, it's going. Okay, so I can only imagine that now I have to make a 1 volt signal of some kind. How am I going to make 1 volt now that I have this battery feeding that? I have 5 volts. I can take 5 volts and I can scale that down, but I'm going to have to construct another set of harnessing. I don't feel like... Let's see here. What are we going to do? Well, while that's doing its thing, let's see if there's anything new with the output. So the output, by the way, let's just cycle this so it doesn't turn off and go to sleep in the middle. Yeah, the input and output is still doing stuff. Let's just ground it. What if I just take it and I ground it? So I have to go find, actually, hey, check that out. Every time I'm looking for something that I need, I find it. Are you actually intact, though? Let's find out. I'm going to plug in 75 ohms and then put that there. I've been burned by these things before in the past, so let's just check. This should say 75 ohms when I go to that right there. 75 ohms. Okay, so I know that this little jumper is good. I probably should have tested the other jumpers, but they're obviously working, so. Okay. I'm going to take camera 1, and I'm going to ground the signal and ground pins. I'm going to jump those together. So now, if I go back to, I just took my, here's the other one. Let's do that. Okay, so that says grounded in that switch down position. I just put the switch to the middle position, and now it's going off and doing its own thing, and switch to the up position, it still has gone off and it still is doing its own thing. Okay, so what was the whole point of this? Now that I've gone down this long tangent trail, I want to short circuit the output of the Hobby King mux. So how am I going to do that? I have to give it a 1 volt reference. Can I do this, by the way? Yeah, I'm pretty sure that the amplifier output buffer stage, it's going to be able to do DC to whatever the 6 megahertz AC component is. And it has to be perfectly linear, and it has to reproduce 1 in, 1 out, 0.1 in, 0.1 out, because video signal, if I understand this correctly, has to be properly referenced on the whole vehicle. So I already have a potentiometer here that's ready to take 12 down to 1 volt. I just need to take 5 down to about 1 volt. And I need to be able to get, okay, I'm out of jumpers now. What I need is a male to female jumper. Oh, where's my bag of wires? Something in here should do. Is there nothing? Okay. That's hazardous, but I'm going to do that because I'm lazy. I have here a servo pigtail, and I'm just going to, so I have to take 5 volts from here because that's the nearest 5 volt source, or you know what I could do, 5 volts is coming off of that, so I could just directly wire it. I have multiple options. So that's making a perfect 5 volts, and I just wanted to drop that down to 1 volt reference. It already is ground referenced, so all I have to do is take the positive and then route it through something that's going to make 1 volt. If I had my power supply here, desktop power supply, it doesn't matter, I'm still lazy. I don't want to get it out, and it's faster just to quickly solve this way. Yeah, 5 volts. 5 volts here, and that should still be grounded. It's not the same ground though. What if I introduced the same ground to it right now? No, let's just not to tempt fate. Let's just do this. It should be easy enough to dial it in. Let's just, there we go. And that is definitely 10K, it's 1K, right? A 1K with 5 volts shouldn't mind too much. 1K and 5 volts, just don't take it down to the rail. I could use 75 ohms as a, by the way, that still is the output. So this guy minus, now what I'm going to do is I'm going to take the signal input, and I am going to use the 75 ohm resistor. If you will kindly stay stuck there, bud. Okay. That's going to get the output. So now I just have to give it 5 volts from this guy. And I need something longer and straighter than that thing. Let's find this will do very nicely. So that, I'm not taking off ground because the ground is already implicit. Ground is coming off of that, and that's the, okay, again, so that is the video out. I am running out of 75 ohm resistors though. Okay, I'm going to use that 75 ohm resistor later. Let's use, I had a bunch of dumb values running around here. There we go. That looks like 47. What's another one? That'll do. 470 ohms-ish. Well, it's not quite 75, but we'll protect. 7, yellow, purple, brown. Yeah, 470. For an input amplifier, it shouldn't mind 470. I mean, I'm already dealing with a 1K, or whatever the Thevenin equivalent is going to be there, so just to verify, absolutely totally sure, I have that, and this is happy, okay. And by the way, to test short circuit current, I'm going to be able to flip that switch really quickly, and it'll only, yeah, it will only tax the output amplifier as long as I flip that switch. So I don't even have to handle the circuit. Okay, so 5 volts is going to go there. Let's disengage that. Well, what now? I just flipped you. You don't have to worry. Okay, fine, whatever. Just gonna flip that right there. This is 5 volts. Be careful where you stick this, Steve. And let's push the potentiometer to a value of about the middle. And we're going to want a voltage from you. And okay, fine. Let's take this one back out. So right now you should say nothing. And now if I connect you, 2 volts. Okay, so now I just want to push you down to about the 1 volt level. Wrong way. 9.8 or 0.98 is fair. Okay, so now 0.98. Let's do this. 0.98 to the signal input. Let's look at what the output is doing. So let's grab this. use that to figure out 0.98. Cool. And now, nothing, 0.98. Okay. By the way, let me just check the feed. Also getting hungry. I was going to get lunch, and I was going to wash off the Canopy and allow the Canopy to actually be a normal or Sailplane component again. Coming up on about 3 hours. According to this, it says it's live. And I am full screen, and according to this, I'm live, and I have no concurrent viewers, which is fine. Okay. And thank goodness I haven't been muted this whole time. That would be really awkward if I looked and saw that the webcam audio is muted. This would have been a very, very silent feed this whole time. Okay. So now for the moment of truth. I have about 1 volt output. I can tune that. So looking at the actual amplifier output in this whole chain, that's very tuned early. Okay, I want to get exactly 1 volt. That's as close as I'm going to get to 1 volt, I think. Alrighty, now to short this. So in this little complicated thing here, there's our 75 ohm resistor. That's purple, green, black. I'm going to have to pass that current through, though. So to let's do this. I'm going to configure the meter to the 10 amp output. And so worst case, I'm not going to even draw a few milliamps, but if I, there we go. This is going to short the output. Definitely sure that's there. Okay, let's do this. 75 ohms, and yeah. Okay, we're safe. Let's go to the next level, which is the 400 or 40 milliamps. There we go. And we're at 1.47 milliamps. What was I doing again with this whole thing? It was to determine if there's a 75 ohm resistor on the output of the video mix. So I think I've just determined that if there was a 75 ohm resistor. Okay, all I'm doing right now, well, let's short this. Okay, here we go. So 1.47. I guess one way to implicitly discover this is if the current doubles, that means that it is 75 ohm output. And if the current doesn't double, or the current is going to go a lot higher. If the current doesn't double, but it goes up fantastically higher, that means the output resistance is lower. V equals IR, R I is equal to V over R. Yeah, so this could be, here we go. I'm about to short the output. And actually, I should have, I just tapped it, but to be fair, let's go to the multi-amp condition. I may have just blown my output fuses if I shouldn't have just tapped it there. Okay, let's tap it there. 0.1, okay. So I didn't just fry, hopefully, the output buffer. Shouldn't have. Silicon, it's limited by the heat when you short it like that. Okay. So 1.65 milliamps. 1.65 versus 1.47 milliamps. And that's shorting it. Am I absolutely certain I'm doing this correctly? Yeah, I'm shorting the output directly to ground, because this is ground. That resistance, if I quickly analyze the resistance of my multimeter, that should be very close to basically 0, yeah. So yeah, I'm basically, let's go to the finest option now then. Let's get the really accurate. So 1.4 milliamps is the shorting current, and through a 75 ohm resistor, it's 1.278. And open circuit voltage should still be holding at 1 volt, 1.027. So let's quickly go record this, and I'm going to have to measure it all over again because I can't remember all of it. I'm not going to rewind the video. So back here, let's take out my favorite thing in the world. Okay, 1.028 volts. Voltage, there we go. And let's just verify that reading. And wiggle the sticks because I know it's going to make a big fuss when I leave the transmitter. Yeah, 1028. Okay, and through what is very close to 75 ohms, I have 1.278 milliamps. And let's just make sure. Okay. Short voltage, short, and pure short. $1,408. Okay. And let's quickly put that to voltage. 1.8 milliamps. Okay. So what does this tell me? Well, the Thevenin equivalent, open circuit voltage, short circuit current. But it says transconductance. I feel like from the 60s and 70s and 80s, we've somewhat lost some technical terminology that they don't teach in modern classes. I never got transconductance, transamplify, whatever. By the way, I'm coming up on 3 hours. I'm going to let this keep going to 4 or 5. Still not accomplishing much today. So I guess these are good studies. Making these recordings, it's a good study in how efficient you can be as an engineer and how much time it takes to do something. So let's say 1.028, and I can't actually use number pad, multiply, divide, minus keys since I use those for starting and triggering the open screen broadcast service thing. Let's see, open circuit current, short, yeah, R is equal to V over I. V, open circuit, divided by I, 0.001408. That's going to be in the K's, 1K range, 730. So that indicates about what about this difference in currents that I'm getting? I think they should just stack, right? So let's try this. 1.028 divided by 804. So 730 ohms plus 75 ohms is about 805 ohms. So what does this tell me? I'm not sure. well, let's go to this. So our drawing board here, let's make a, so that was the video, not knowing quite what to do with the video transmitter with its receiving circuitry. But for the, for this, we have an unknown resistor. And what I've basically done is I've tested that unknown resistor with two conditions. I've basically tested it with that, and I have tested it with just a short to ground. So these are basically the two things I've hooked up to it. So unknown resistance, but I know the open circuit voltage and short circuit current, and what I'm trying to separate though is what am I trying to learn from this? The whole point of this was, can I have the Hobby King, does the Hobby King have 75 ohms on its output? And what happens you don't know if you were shorting that perfectly. And you were only measuring the current there, but you didn't measure the voltage, Steve. What was the voltage when you had the 75 ohm resistor shunted in? That is one piece that I'm missing that might be useful. I think that might overdetermine it though, but right now, especially presenting like this live, I'm not really, by the way, flip the switches, make it happy. Okay, so we are going to short through 75 ohms. Being careful to only touch I want it to. So there's 75 ohms, and that's exactly what it's going to have in the case of, say, the... Okay. So there, see, it's replicating 1.028 just fine. So that's not shorting. It's doing just fine sustaining through a 75 ohm load. Where was my second 75 ohm resistor? Because I had two of them running around. I don't know where I put it. And, yeah, what am I doing? I had two 75 ohm resistors, and I don't know where I put them. So I'm just going to put in a second 75 ohm resistor, and we're going to see how well this thing does. What, I think is going to happen. Okay. So I don't know where it went. It's AWOL. I thought I had two 75 ohm resistors. That's a 470 something ohm, which is the reference voltage. And I don't know where I put anything. So yeah, here's to a second. Oh. I didn't want that. Okay, that was in the wrong spot. Okay, never mind what just happened in the last minute and a half. This is the true. Okay, I need to do that so that doesn't happen again. Okay, here comes the true 75 ohm short test. Because all I did is I had 1 volt going to the 1 volt input. That didn't do anything. Okay, there we go. That's the true grounding. Now let's see what happens. 1.28 maybe? Oh, it collapses. Check that out. It actually collapses. But it's definitely not capacitively coupled. But it is definitely collapsing. Okay. Okay. Now this is a very useful voltage. So 109.9 millivolts.
And let's plug in the other 75 ohm just to be sure, just for variety. That should be, again, 109.9. Pretty sure these are very well matched 75 ohms. 109 point, let's just put it at 109 millivolts. Okay. So that's an important zero, 10.0 volts. Yeah, and that it was overdetermined. I'm fairly certain it's overdetermined because I is equal to V over R. No, V equals IR. V divided by R. One, 9. Yeah, I'm solving for R, and I should get 1.28 milliamps. 975. So 145 milliamps actually. What? Times 75. Okay, so 95 millivolts. Yeah, so that was basically overdetermined. Okay. Now I'm giving it 1 volt. Let's try it at a different open circuit voltage. So let's go back here and let's give it a 0.5 volt. And for curiosity, it should have relaxed back up to 1.028. Yep, there we go. And let's have it go down. Half. Hey, I just about got it right on there. 500 millivolts. $59.2. Non-linearities. Let's just put that at 59 millivolts. So, phone buffer. Okay, 59. Was it 59 or 52? Can't get that right. Okay. Yeah, 59 millivolts. 9 millivolts. 0.683 milliamps. Okay.
Okay. Which looks like it is half. Okay. And what's the dead short condition?
Just doing this. 0.760 milliamps.
Disappointing, or it's confusing, because it would mean even under the normal operating conditions, this thing is inappropriate. I don't get why. Shouldn't it be able to drive at 75 ohms load, the input signal completely intact and to scale? Why is it attenuating when you give it a 75 ohm load? It's like the Hobby King videos, which are, I'm really confused. Because for sure, absolutely for sure, that was with it inert though, right? Did I measure it when it was hot and active? Shouldn't matter. I mean, if it's inert and you're getting 75 ohms or 71 ohms for the video transmitter, then you don't want to measure that when it's hot anyway. Yeah.
Yes. Well, I'm going to discontinue this for now. This is only making more questions than it is giving me answers. So, what have I determined for sure? That was one long tangent. It was a tangent of figuring out what is the output capability of this, and that was gone too because I was wondering I have to ditch the whole video distribution amp in the first place because I chose the wrong IC. Because the IC isn't rail-to-rail, can I give it a 6-volt floating reference? That is the next thing I can quickly do before I just call it quits for the afternoon. I've just disconnected that. Am I ever going to reproduce this experiment again? It's all captured on video. I don't think there's anything new I could add to it. I've gotten 2 sets of data at the half-volt condition and at the 1-volt condition for pure DC operating point. I measured the shorting on 75 ohms I measured it on 75 ohm mode and shorting, and of course open circuit voltages. And that is just to verify with the input known and the output known, and the input, there's no reason why the input resistance, it only measures voltages. It's not a current feedback device. It is purely voltage replication, right? You measure voltages. The signal is articulated in terms of voltage levels. So, anyhow, where was I? I'm going to redo our amp. So let's disconnect that. Put this back together. That was there. Nothing's hot. Nothing's alive right now. Everything's turned off. Okay. So, I have to find a way to, oh yeah, the problem with that is can you capacitively couple that? No, you can't. I already answered that question. Why am I going back to trying to float it at 6 volts off of the ground level? Because you can't do that. Because you can't have okay. Things are just getting really complicated. what I've learned thus far, my findings thus far should prove or demonstrate that I can't even use the Hobby King video mux. Is that the truth? Can I use the Hobby King video mux to drive a signal through? From what I understand, no, you can't, because that's 75 ohms. You know what I need to quickly do? Let's turn on the, I'm gonna turn on this guy, and I'm gonna quickly do something. We need to measure the input resistance on this guy here. What I did in early testing is I had these two shorted together, so the camera output and input, video transmitter input are basically soldered together. I'm going to quickly desolder that so I can measure them infinitely. So, this is the point of the bubble wrap, and yet I have all this very dangerous sharp stuff that's going to mar and dent the foam. So, trying to gingerly sort of, I'm just going to do this. And I hear things falling off that I don't want to falling off. Well, okay, so that's heated. All I have to do, okay, and just to show what's going on. Don't flick, please, thank you. Yeah, not around the phone. Okay. And thermal cycling, that poor probe tip. Anyhow, okay, there we go. Let's determine for ground there. Okay. Let's look on our chart. So the tail. So what is green is video input. So I wanted to measure what is resistance between video input and ground, because that's the VTX, and that should be 75 or 71 ohms, because that's what it was for its other sibling that's living in the wing. The sibling in the wing is basically that, 71 ohms. I didn't bother to measure the capacitance though. I mean, when you have 71 ohms, there's really no way to get a meaningful capacitance measure anyway. If I'd measured infinite impedance, or yeah, if it had gone infinite, then I would have measured capacitance, but it was 74. Yeah, so, by the way, that transmitter, this guy here, which was the VX, or XV 579 or 599, yeah, I didn't say anything about input impedance, or if it did, it would have said 75 ohms. I'm going to verify that right now. So video in, green, black and green. Okay, so let's make sure that's visible. Hey, come back. Did you just run out of the battery? What are you doing? Okay. I love that multimeter, by the way, but it also has this silly idiosyncrasies. Anyhow, you should be 75. What are you? You are 78.3 ohms, and that is inert. The device is not powered, but I can't imagine why powering it would do anything to change that input resistance. It's 78 ohms to ground, in addition to, like what we saw in that thing there, you have input amplifiers of some kind, and it's basically directly into the input, maybe with a series resistor. So having the amplifier powered or not shouldn't do anything much to this. So 78 ohms. So I'm left to wonder, maybe we should go to our transmission line analogy. What happens? Well, I measured that. I just did that. I just did the toy demonstration. I demonstrated that when you have an output amplifier like this, what if it has its intrinsic resistance? Let's study this. By the way, is it about to barf and get mad at me? Let's put on a 700 something resistor. I don't know, 700, sure. I just want to study what happens. So reset, run, stop, run. What did I do to you? Oh, 700, yeah.
So that severely attenuates it. And I am measuring that should highlight. Yeah, there we go. So that's what I'm measuring, is one of the two being fed. By the way, I didn't properly terminate that when I was quickly. So I have to give you, I think this is, no, I have to quickly reproduce this now that I just discovered that I made that error. So I was demonstrating, okay, so let's put you there, okay, and reset, okay. Oh, new ground, what? Need to ground on transmission, what? Oh, right, okay, let's just pull you over there, okay, reset, there we go, and run stop please, thank you. So this was demonstrating the 1/3, 2/3 thing. Oh, actually, check that out. Okay. Wait, what was I doing? There was no point. I'm getting weird now. Is what's going on. I'm getting weird. I'm tired. It's the middle of the afternoon. Okay, let's reset and do that over again. So there's the 2/3. And you have two video transmitters with 75 ohm coax or something like that. So they're properly terminated, there aren't reflections, but you are having the signal level. No reflections, correctly implemented, just having a level. Okay, so now let's just replicate this. So copy, paste, just to see what happens when there's, that's what already is captured by that 75 ohm. I haven't done anything new. All I've done is, okay, reset. Well, it shows that the situation is exacerbated. Seems fair. Let's do that. What? What? Okay, get rid of the silly. I shouldn't have. I was just in a rush. Let's just do this. I'm going to get rid of that. And I just want to study what happens when. Let's pull that all the way out. Okay. No. There's this. That. Okay, there we go. Reset. So there's the prime. Here's the ground truth. It should be the same. Okay. Yeah, so you lose signal. And now, if you have a slightly off, or even, let's do 300. I'm just going to do 300 as opposed to going up to 700 like what I measured, just to get a silly 75 ohms, 75 ohms. So this just shows that your output driver is mismatched, but the load and the cable are 75. So now if I reset, Never mind the fact that the output voltage is severely under even for the nominal case. I'm only looking at the difference, so I'm looking at how inappropriately feeding. And now, if you go there, so even though you have, oh wait, what am I doing? I want to demonstrate that. Okay, I want to demonstrate that you have, what am I trying to accomplish here? I don't know what I'm doing. Okay. Reset. What am I accomplishing here? Well, now they're equally matched. Well, yeah, duh, because it's two completely separate independent paths. Okay. This is not yielding any information I need to know. So here. I should go display only. I was probably skipping a bunch of having the picture there. Yeah, so we go here, we have that go there. With that, you have it fully attenuated. Here's 5, reset. Yeah, now it's a 2/3 relationship. I'm not sure how else to mix this to try to determine what's happening. Other than, well, yeah, I went to this thinking, what would explain why the Hobby King device is doing what it's doing? It's just annoying to me that the COTS solution is actually bad. The COTS solution is actually, as I understand it here, inappropriate. Why is the Hobby King output impedance about 700 ohms? Why would it crash the voltage to? Why would the voltage? You need to put in a real signal, Steve. Get a real signal out and get out the oscilloscope. That's the only solution. That's really the only thing you can do right now. Try to prove it. Prove that the Hobby King output. But I have to understand why. Why does the Hobby King output for DC? How does it do that? Why is the output driver not able to? Why can't it sustain a 75 ohm load? What should it be driving, Steve, on a 75 ohm load? If you wanted the voltage to be if you wanted it to be 0.5 on the input, the current would have to be what? So I is equal to V over R. So 0.5 divided by 75 would be 6 milliamps. So the output driver needs to be able to drive 6 milliamps, and it can't even drive 1. Do you think you have a dud device? I mentioned that in the feed an hour ago about that I had 2 in case one was bad. And I don't actually know the true origin of these, if they have been abused. Maybe the output on that, but no, it was, why would the output lose current carrying capability? Maybe if you fry the output driver by accidentally cross-connecting something from its past history, maybe it has enough silicon left that it is able to push as it's supposed to, but it just doesn't have the output carrying capability anymore since it was overheated and fried. Let's get the second one out. I have to repeat this all over again now. All I have to do is repeat the shorting test, though. Man, this is really getting, there are a lot of tangents here. But this is a complicated machine, and it does need to, yeah. Let's just quickly directly replace this. It's odd. No two devices are exactly alike.
There we go, we're fine. I'm just not paying attention. Okay. There we go. So minus and plus. Signal. Okay, so I've transposed that, but I said I wasn't going to reproduce this, but now I need to reproduce it all over again. Huh, what have I done? Okay. Oh man, that was close. Okay. By the way, what was it, 78 ohms? Let's just put 78 ohms. I don't want to have to redo that measurement over again. Okay. So much to do. So much to do. Okay. So, I didn't measure anything else to measure, just, yeah. Copy, paste, video input. Just make sure it's nicely matching. That was 78 ohms. Inert. I'm not listing that was an inert measurement, but this is so precarious. Well, yeah, drawing harnessing diagrams and KeyCAD is precarious and sloppy. Well, it's what I've got, and it doesn't have to be sloppy. You can make it look nice. I've got to work with what I've got. So, and it's not the medium of articulating it that counts, it's that the engineering is correct. Medium and polish can come later, if I ever do get it polished later. What matters is I capture the information in the way that works for me. And if I try to share this, that's what I'm panicking about, is I would love to share this with a lot of people. Let's see here. Yeah, so naive, implementation. Stopped, it's going, okay. So quickly reproduce the entire circuit. Okay. So that's coming back. That is ground. And it's all coming back. Okay. Okay, that's fine. Okay. So this source, camera, one signal, got the center feed. Okay, ground. And I had to have the +5 coming in here. And then I had this coming off for the multimeter. It's alligator clip to hold on to. Okay, so I've directly transposed. So yeah, I really hope it's just a dead faulty device. If I can get 6 milliamps on the output, that would be amazing. This is definitely 75 ohms, which will be available as a shorting method. We have this thing back to voltage mode. Okay. And this guy is ready to plug back in. I can turn this guy back on. It's ready to go. Receiver is powered and is powering this. How do I know there wasn't a 12 volt requirement? I'm really hoping there wasn't 12 volts. Could that be it too? That's something that I was, it wasn't in the Hobby King specs for this stupid thing. I can quickly determine. Let's go to, so I have ground. One thing I can do is I can measure resistance. Hey, come back. Come on, bud. Let's measure resistance from the positive pin to ground, because it should be, when I measured this last, it's basically infinite impedance. So any one of them should do, the output plus feed, because it has to be the bus for the entire camera system. So let's just verify this is what ground looks like. Ground on the multimeter goes to 0. Now it's floating, and now if I go to, yeah, it's floating. The plus 12 volts should not interact at all with anything on the Hobby King video switcher. And I determined that with, yeah, now I have to question, are both of these pristine examples of the device that I'm testing? I love systems engineering. Okay, let's just verify if I'm going to power it up. That's going to, let's make sure that's not connected. Okay, and that is definitely the camera output signal is red. Okay, let's plug this back in. Okay, how are we doing? We should have, if I measure using something sticking out of it. Come on. And oh man, that's not what I want. Okay, thankfully multimeters are somewhat tough. I've done that many times before. Okay, so point, and I'm accidentally touching it, dang it. I accidentally tested the pajamameter and well, let's put it up to 1 volt. 1 volt was the, and yeah, that's close enough. 104, 0, okay. So, 104. And is this live? It's blue. So I should measure here 104. Okay, and now if I short this, and I think with the first one, I shorted through the 75 ohm first, right? Yeah. Let's do the same thing. I should get 6 milliamps with this. Why are you in micro? Oh, yeah, microamps. Okay, here we go. Please be 6. 1.2 milliamps. So 1.291, which is basically where I was at with the other one. 1.75 ohm. Yeah. Let's make sure I do the inference there. Infers is the error symbol. I'm about to say short is also the same value. Let's find out. Should be 1.4 something. Yeah, 1.423. So either both of the devices are dead. Yeah. Okay. By the way, I need to save this. Or, well, I'll just basically push the important bits of these notes. This is technically a lab notebook. Right here, what I'm doing with Notepad++ is technically what I should be doing in a lab notebook. And I do have my lab notebooks that I've had for years, but I only use those when I'm recording weights or I'm doing other prototyping on the bench, and I'm not casual like this. Nice. Okay, so that follows up that tangent. Tangents upon tangents upon tangents. So basically I've determined that the Hobby King video switcher can't directly drive either of my transmitters without having the signal collapse. So now I'm just curious, if I were to plug this in, let's get a camera out. And I have to get out the oscilloscope. And I'm not going to stop the stream for that. I'm going to keep going. I'm going to solve this. So, where did I put the camera? I cleaned up. I cleaned up the room, or at least I've cleaned up this table. But, no, I'm still lost. I still can't find anything. Okay. So video amplifier. I can definitely do the microphone. I just have to cut the cable off of that tip ring sleeve connector or figure out how I'm going to ground that. I can quickly, task overview is what I'm doing. I can 3D model this any time of the day I want. I just have to take the marker and mark lots and lots of tattoos on it. Quick overview of what else I need to accomplish. So, yeah, I keep having second guesses in my mind, like, are you sure you did that correctly? I'm being far too thorough, is what's happening. The naive approach, though, would be to just buy off-the-shelf parts and just wire them up and not. This is my masterpiece. Everything I make is a masterpiece. As usual with any engineer, I need to just. I'm trying to be self-conscious enough to know that I'm probably wasting time, but this is totally wasting time. Let's see here. This is definitely not something I could do every Saturday. This is a lot of work. Let's see here. Yeah, there's so much work to this. This is a full-time job. By the way, let's turn off the soldering iron. Okay, now what? Yeah, I need to figure out what this. I need an NTSC video signal. Can't find any where I put that. I mean, the camera. Did I cycle it in here? I did, didn't I? I decided that this was going to live in here, and now I want it back out. Right? Where are you? Okay. I need something that generates an NTSC video signal. You know what? I happen to have that solution right there. It's called the Toothless 2. Toothless 2 with its assorted harnessing and things that it came with. But I don't want the Toothless 2. I'm trying to find where's the ready-made RC Pico Wide. Because that one already has the pigtail soldered on it. It's already ready to go, and I think it goes down to 5 volts. So that one is ready to go. I could use the Toothless 2, but I'm not ready for it. Okay. No idea where I put anything. Where did I put anything? I'm really feeling like just chopping the stream at this point. I have 15 minutes left to the hour. Where did I put anything? Yeah. Hey, what? Okay. That's not super annoying. Anyhow, here's the Toothless 2. This should do very fine in generating an output video feed. Let's see here. It actually is already formatted for directly connecting to the Hobby King. So let's do this. I just have to give it a 5 volt to, well, let's pull up the data for this. Let's go to Google Keep, which is very hazardous since they have memory leak in there. Yeah, according to this, 3.6 volts to 24 volts for the Rainmate RC. Pico-wide V2, which is long since out of stock. They don't make these anymore, but man, isn't this a cute little camera? It's smaller than modern micro cameras. Or it's about the same size. Yeah, it's basically the same size, if not slightly smaller than modern cameras, like the Foxeer Micro or Nano line. But yeah, let's plug you in. And can I really trust the wires are what they say they are? They better be, otherwise this doesn't deserve to live. Okay, so signal, there we go. And that, all I have to do is flip the switch to the center position, which, or rather camera 3, which is going to be the opposite side then. And that should make NTSC just fine. I'll need the oscilloscope though to measure this. Also, am I going to actually drive it to, I need to solder up the harness. Do this. Can I do jumpers? I can totally jumper it to the wing. I don't have to turn on the video transmitter, though turning on the transmitter would verify the integrity of this. Yeah, basically this is devolving down to let's test the Hobby King Video Max. Yeah, do I want to do the tail? The wings are already been formed, so I can just plop the wing here onto the table. Okay. Let's very gingerly disconnect those two, and I can take that out. Okay, so the circuit board is not participating in this. Instead, we're going to have the wing come out, and we're going to do an empirical. We're going to do a very quick empirical survey. I never used this. Let's put this back in this bag. Now, seriously, am I gonna I could just go through the tail. That would give me 5 gigahertz. Let's do the tail. So let's do the tail camera. For the tail transmitter, which is 5 gigahertz. It's more modern anyway. It also exhibits the 71 to 78 ohm impedance. It represents one of the 2 video transmitters I'm using. Okay. I'm going to have to jumper it since I haven't actually soldered up the harness yet. So in that case, let's go for ground. Ground, and then how is that going to be powered? So 5 volts here. I'm going to have to give it an alternate 12 volt source. What is it? Okay, I have to go back to my references. So back to Google Keep. And back to FPV component info. The transmitter. Okay, so the transmitter says it can go from 7 volts to 12 volts, so I have to give it 12 volts. I don't have any 7 volt source. The next step I have is 12. So that's going to be feeding 5 volt system locally. I have to get a second battery. So let's do that. Let's get a second one set up. And let's do this. Well, actually, I have a little screamer, but I'll put the screamer back. 11.3, 1298, 12, or 398 rather, and this one is 338. Oh, it's hurt. Okay, how about this one? This is my favorite battery pack for testing the MPPT. This one's 11.2, it's got 37, 374, 380. Yeah, that's fine. Okay, so that's going to be my 12-volt system. I have to join the grounds though. Okay. So one thing at a time. So I have to power the video transmitter. How am I going to do this? I'm going to have 12 volts going here. Okay. And then I'm going to have a red jumper like this with its protected tape. That's going to go to power this guy. And I am absolutely positively sure that red, I'm not colorblind, hopefully not colorblind, the tail, 12 volts is red. Okay. So, I can get that to, there we go, gotcha. So that will be able to plug in just fine. Actually, let's just take out ground and then plug in red. And there we go. So now that's ready to be joined. It's a lot easier. I'm going to do that. Okay, so now I just have to join that ground to the ground being used on this. And then I'll also have camera and then video out. Okay. Okay, I do need to. I need more alligator clips, is what this comes down to. I don't know where I put any of my alligator clips. I didn't tear a bag. Once there was a bag of clips. I haven't seen that for a while, actually. That's probably been packed. Okay. Here. Where to put it? Approximately half of my day is spent trying to locate something. I don't have a nice lab set up. I mean, I have my lab. This is my lab, but it's not well set up. I don't have a nice garage lab with a large wall of tools and all of it perfectly organized. Instead, I'm living transiently, and I have everything in bins. I don't have a very good, I quickly look around. I have a distinct lack of testing apparatus right now. Let's do this. I can just, oh, look at that. It sticks out there. So, video output, ground, and signal. Okay. Ground, signal, okay. Ground, if I could find a way to get this ground to scurry up there. Can I get you to fit? There, I'm doing this without alligator clips. This is really silly. And then there's green. Green, can I reach green? No, I can't. I have to come around this way. This is so sketchy. So sketchy. If I had, I don't know where I put my alligator clips. Not alligator yeah, the alligator wires. Hey, check that out. All I had to do was reach further. There we go. This is way better. Way, way better when you find your secret stash of alligator clips. You don't have to improvise wacky solutions. Okay, that is much, 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 much better. Okay, so I'll have you piggyback on that one. Yeah, I'm gonna do this. There, and now the video signal gets to go to what is green on the harness, because white, let's be absolutely sure, tail, white wire, video out. Okay, I don't want to have video out to touch anything. Oh well. Yeah, I just realized, there's a camera in the tail that turns on when you give it 12 volts. And, but that would have been fine, actually. I could have just had another. Okay, well, with that, let's go find the display. So I'd previously used that on the Raspberry Pi. I need to go find, or I can use the Fat Shark. That's not very conducive to a live stream, though. I haven't any clue actually where I put that. It should be somewhere in my large detritus that's floating around here. Ah, there's evidence it's here. Oh, yeah. Gotcha. Found ya. This is it. A completely self-sustaining, independent, battery-powered source here that will listen. And I believe we're on A1. Let's see here. I want you to go from source from AV cable to diversity, and I want you to go to, channel 1. Let's change the band. Actually, I think band D1 was fair too. I'm at point blank range. I don't need to have any antennas on. Anyhow, let's make sure that this all shows up in the feed. Yes, there we go. Okay. So with that up, let's power this on, and then I'll power on the transmitter. So powering on the transmitter is with this guy. Otherwise, the transmitter is inert. That goes to signal output. By the way, turning you on. It is a contest between position 1 and position 3. Now we're on camera position 3. There's nothing on position 1. Okay. And we should see the camera basically looking near field. Okay, and that's signal positive ground. That's negative, negative, negative. Okay, let's do this. So that's on. This is blue, okay. Nothing. And now, point blank range, it's gotta hear that basically. And, well, what I think is going on is I have to change the band to the A band. We are, yeah. So why aren't we, do I have to plug in an antenna? I thought point blank range would be sufficient. Okay, now I have to, first of all, I'm having things get hot. Let's not let that happen. Okay. Let me go back to the Google Keep document again. Right now it says channel A-1 is 5865 megahertz. And if I go to the FX7909 Tango 5.8 gigahertz transmitter, and I think A1 is 5740. Okay, so that's why I have to go to the D band. 5740. Okay, 5740. 5740. Okay. 5740. So they are on the same thing. I know that because from prior research and knowing that the lights on that, it's basically group and then channel. And if the lights are on that one position, then there you go. So there we are. So now I have to get out the oscilloscope to demonstrate and prove that what's actually happening here is that I'm not going to blow out the front end on this if I do plug in a transmitter antenna, will I? Let's go find 5.8 gigahertz. I believe one of these will do. Yep, 5.8 gigahertz. I'm going to attach this somewhat far away though. Oh, look at that. This actually takes the oh man, it's the immersion RC. It's a different polarity SMA connector. Okay, I have to go find the let's just pull it out of here. Here's the Foxier orange. As I'm screwing that in. But ta-da, there's nothing. Oh, duh. Okay. Moment of truth right there. I just flipped up this receiver. Dang it. And I am at point blank range. I don't want to fry the front end, so I have to give a few feet of distance. It's only 200 milliwatts, though. 200 milliwatts shouldn't fry any kind of receiving front end. It's definitely on A. So I think this is receiving. It's just receiving black. So why is that? Why am I getting black? Is the camera working? Oh, you know what? I'm not giving... The camera needs 12 volts, of course. The camera needs 12 volts, Steve. Okay. The camera needs 12 volts. Okay, this is ridiculous. Instead of going through this camera, I'm going to basically pull off of the known good camera. Let's turn things off. I don't want to fry anything. Okay. The known good camera that's transmitting along the white wire. And let's just, I don't have any more pigtails to plug in. I'm just gonna very gingerly, very carefully. No, I'm not gonna do that. I do have this though. That works, sort of. I do need I'll just plunge a resistor in there, or I can use a wire. Let's use a wire. Do that. Okay, now I can, for channel 3, have, and by the way, this is totally not honoring any kind of impedance matching at all. This is, yeah, doesn't matter. Okay, so now let's take off the antenna. By the way, this has one of my adapters on it. Huh. Okay. Okay, and ta-da! Check that out. Okay, so it works. I need to understand why. It's time to get out the oscilloscope. This is good for me to really learn how NTSC is distributed. And this is actually going back 7 or 8 years ago. I taught Daniel Hearn, and then okay, anyhow. I wish I could pause the feed right now while I pull out the oscilloscope, but I'm not going to do that. so precarious. I can't touch this. Let's turn that off. There we go. Oscilloscope time. I have to know. This is going to bug me. This is going to make me stay up late at night, waking up in the middle of the night wondering why the heck does it do that? Why can they get away with having the output sag and not do the 75 6 milliamp thing? Oh, okay. Come here. I got you. Okay. So, got this guy here. So let's replace one display with another. Going for you. Okay. Thankfully, the Rival 1054Z does have the NTSC trigger function in its acquirer abilities, so we will make good use of that. Let's see here, there's the other one. Okay, I didn't think I was going to unpack this until I had moved from Boston, but here we are. I have an important question that I have to answer. Why the heck can the video switcher get away with having a lousy output driver? Why the heck can it do this? So, there, and then that. That's the output. I wanted to go after the camera, and that is fair right there. So I actually have to compare input and output. So that means I have to get a second lead out. I want to compare and understand why. By the way, do I even know what the input resistance is for the Hobby King Mux? I mean, the input resistance, I measured that, and that was nothing. That was infinite impedance. But now I have to check to be sure, so. Okay, yes, I know, little mistakes. So right now it's inert, the device is off. Oh, okay, fine, let's do this. I'm going to have alligator clip upon alligator clip upon alligator clip. So that, happy. Now let's verify that that's actually connecting. Okay, it is. So Hobby King is incorporated in the system, so let's go find a non-used camera input and figure out why. See, the input impedance on that is infinite. If I look at also the positive pin, it's infinite. If I look at the ground line, it's a 0. Again, single input is infinite. And it's powered too. Right now it's alive, it's powered. So if there was any kind of, well, of course the input impedance should be infinite. What happens when it's a depowered? It doesn't matter. The point is there's no 75 ohm terminating resistor. Okay. Okay. So let's basically try to do that. And then, where did ground go? There's ground. This is so bad. Okay, there we go, and so green is being sampled. Let's try to get yellow. Yellow, I can sample right there. Okay, and nothing is touching. It's a miracle. Okay. Now, out of this one will do. I'm running out of power outlets. Okay, and I'm not sure this is gonna reach. This is not gonna reach, is it? I need a cable that's gonna reach. Oh, please reach. Oh, it totally makes it if I take out what looks like power tool of some kind. Okay, there we go. Well, okay. Whew. Okay. So just to verify, yellow cable, yellow cable is green, green is white, white is the output from the camera, right? White is the output from the camera, and green is the video input. Green wire, which is actually yellow, is video input, and it's all measured, it's all grounded. Alrighty. And I don't even remember what I configured these channels for. DC coupling, course, okay. So let's did I just center that? Yeah, position zeros. Okay, and they're all scaled for 2 volts. I'm going to scale them for 1 volt. Okay, and then the trigger, I want you to trigger for, well, channel 1. What are you doing? Source, channel 1, type. This is where I can actually say type is a video. Polarity, but if it triggers on video, sync all lines, standard NTSC. I actually don't know what I have that camera set up for. And I have another, by the way, sorry for blocking. Settings, noise reject, whatever. Okay. Sweep is auto, standard NTSC, PAL. Ooh, it can do others. 576p or 480p, which isn't that what PAL and NTSC? I guess PAL is 520 lines, and NTSC was like 480. I can't remember. Anyhow, sync all lines, line, even, odd, polarity, and then trigger level. Sources video. Well, let's do this. That still is active. Drill the sticks. Okay, that is video. Behold video. And just to demonstrate that it is still alive, let's turn this on. Come on, bud. And there it is. We've got video. So it is working. Like so. So I have 2 channels going on here, don't I? So why do I have, let's take a single. They're basically the same. There's something about them that the Hobby King Max that it can't sustain a saturated 0.5 volt, or maybe I'm learning something about how output amps work. How do you know, by the way, when you measured infinite on the input, how do you know that isn't capacitively coupled then? But I don't care about the input of the FPV mux. I want to know the output capability. And I know what it's driving is a 75 ohm load on the receiver. So let's format both of these. Yeah. Insane. Yeah, run. You see lines. Okay. So there is slight differences between the two. And again, there's the output, there's what's coming out of the FPV muxes on blue, right? Blue, red, yeah. So whatever's blue is what's the output from the FPV. It should be the same, but it's not. Oh, what am I doing? Wrong lever. Okay. I don't understand how it's triggering. What am I triggering on? I've gone to 5 milliseconds. I believe that's how it's framed. Okay, menu for that. Clarity. I need help, which is nice. Help for video. Video triggering is used to capture the complicated waveforms of television. The trigger circuitry detects the vertical and horizontal interval of the waveform and produces triggers based on the video trigger settings you've selected. In this menu, you can set the trigger source polarity mode, stand, and hold off. So TV polarity, to set the TV trigger to either positive sync polarity or negative sync polarity. This is amazing, by the way. Rigel, you guys, this is why Rigel is awesome. Well, then again, other oscilloscopes probably have this too. But I mean, yeah, it's nice to have help on each of those. In TSC, the field frequency is 60 frames. I think it's PAL, that's why it's scrolling right now. And so I need to set it to 525. So even field goes first. PAL CCAM is 25 frames a second, and it's 625 frames with the odd field first. Frame frequency of TV, progressive. How do you scroll down? Use page up and page down. Okay, frame frequency is that. Okay, so let's get out of help. PAL CCAM. Now, why aren't you locking to it then? Shouldn't you be locking up? By the way, how is the transmitter holding up? Okay. Clarity. Still scrolling, I have no idea. I don't know if I've ever actually attempted this before. Okay, it's not, behavior isn't changing. Do I have to zoom in more? Hey, that did something. By the way, where is the trigger? The trigger's been out of the way this whole time. I have to set the position there. Okay, that probably explains why I've been sort of stuck. Okay. Maybe. Actually, why don't I just do this? I know what the camera is. The camera, where's its box? The box that the camera came in. According to this, it is NTSC, if that label is to be believed. So if it is indeed NTSC, is there a way for me to find that out if I don't really trust this? Okay, where's clear? Get out of the way, bud. Clear? Okay. So I've nailed it down. I know NTSC is. Ooh, look at that. Well, changing the polarity. Now I'm on a tangent of trying to understand how the eyeball works. Okay. How about instead of all lines, let's try rhyme, odd, and even. So if I want to only do line 1, is this actually working? Is that it? Yes, I know, but by the way, what happens if I do that? Hey, interesting. I've found something. That's interesting. Flipping. So when it selects an input, what is it doing? I have no idea what it's doing. Has it not occurred to me that that might not just be an analog switch, or it's a RF switch? Sure. It's actually The multiplexer doesn't actually have any buffer circuitry in it. What if all it is it's interesting. Maybe. Hey, it's actually working now. Line, odd, even, all lines, line, odd. There we go. There, it's actually right there. Here's a sweet spot. Well, let's go learn more about how TSC works. So, I've got this guy. Sync level is at 0 volts. So basically, yeah, you want the lowest trough. If the trigger is looking for sync level, peak video and +1 volt, 0 volt. Reference white, what's +10? What's 10% bright? Reference black, reference blank. Blank, black, white, bright. Let's go to NTSC since that's what I'm dealing with right now. Please take me to the waveform. That's the bandwidth, but I want to see the waveform itself. Oh, come on. Where's the waveform? Oh, let's try PAL. PAL is supposed to be pretty similar. That only shows me the waveform. I want to see. Oh, there we go. Wikipedia, you failed. I want to go to NTSC. One of these. Yeah, let's look at this.
Thank you. I'll just click on the first one. 1 volt from there to the very topmost line period. So H sync. Thinking. So the whole thing is 5 microseconds. What's the current span? I'm on 2 milliseconds. So 2 milliseconds instead of microseconds. So I'm looking at an entire line, I guess. For 30 frames a second, you need to have 500 lines. Yeah, let's zoom in. Yeah, there's 200 microseconds. There we go. Yes. Wrong button. Sure. There we go. So wait a second. 100 microseconds is a division. What is this? What have I found here? Line period is about ooh, know your video waveform. Here they're triggering. I would actually like to go to this. Let's go to the Hackaday article on this. And here it is in arrival. For 10 microseconds. So 20, 10 microseconds. Going down. What are they doing exactly in there? Sync all lines. Okay, so let's sync all lines. Okay. And then how are they triggering it here and there? They are basically doing what I'm doing. Where I'm pulling on the very edge there and single. Single. Round. That seems to be the happiest setup. Yeah, check that out.
20, 40, 60. Yeah, there's 60-ish, 3. 40, 63, yeah. So there it is. So that's what we want. What happens when we cover the camera? We get noise, and then zoom, and then there. Yeah, check that out. Yes, I know. Okay. So with that established, watch what happens. The whole thing gets trashed. Yellow gets completely trashed, but blue. When the multiplexer selects a signal, it actually is doing something to it. So here's a single frame. And now it's completely trashed. Yeah, let's just measure our other cursors. Manual. Just to give myself a good visual representation. There's that, and then cursor B. Just for reference, it says that cursor B is at 600 millivolts and cursor A is at 1200 millivolts. Alrighty, let's just capture a single. Yeah, there's a single. So now, if I capture single, it's attenuated, but now the blue output. Blue is actually looking really nice now. Blue has basically taken over. Why is that? Why is the input impedance all of a sudden changing if what my oscilloscope is observing is real? Which it really likely is. It's really quite likely that that, which is going into that, which is the yellow, which goes in here. Oh, by the way, 337, all 10.7. Number 1 is at 3.53. Okay, this guy's not doing so happy. Let's find another victim. Is this one any good? 11-0, 368, 366, and 368. Okay, I'm gonna go with you. And actually, let's have this one go, and this one. You know what I'm gonna do? I'm just gonna. Yes, yes. 310. It's about to hit it though. 333, 3637. Okay, whatever. By the way, how hot are we getting? This is good practice. Good practice for when it's just sitting. It's getting very hot. Okay. There we go. Yeah, so it's basically whatever it's doing, it is rendering a viable output signal. Then I've got a source, menu here for this one and source 2, and I go and run. Now what's going on? Why? Why is blue struggling? Ah, there we go. I have to have blue. I need to have, in terms of layering, blue needs to be a little bit higher. Okay. There we go. So now I can take a single. So yeah, there's each of the lines. Yeah. Okay, but blue completely collapses. You go here. No, that picks up right where it was. Okay. In terms of output quality, so does that look about the same? I guess it is. Yeah, it crashes. Crashes that. You know, the big question to answer or to ask is, what happens when you have this feed into 75 ohm? Does the video still come through when you have 75 ohms shorting? Let's do that grand experiment. So right now, we have the video camera going to the video transmitter. Let's just find out if I don't need a video driver after all. The assumption was that I did need a video driver. So, or distribution amplifier to be exact. That is purple-green, which is 7.5. How am I going to do this? This is the sketch moment. Unless, is there a way for me to... So basically, can I drive... Can this guy for green being the... Okay, so I want the green one. White, which is actually green, which is actually red, which is actually yellow, which is actually, okay. So I want green, which is actually yellow, which is actually red, which goes there. Okay. That's all I have to do. I just have to touch between here and the other, and we just have to see what happens to the video on the oscilloscope. So this would represent a second load, a second video transmitter. Let's see what happens. Ah, it does attenuate it. See? It does. It does. And by the way, is that visible? Yeah, that's visible. Yeah, this is 75 ohms. What happens when there is no load? So if I disconnect yellow, what happens? Ah, look at that. It throws everything completely out of whack. There is no output load. But now what happens if I present the 75 ohm load? Now it's happy. It's happy now. It's at that exact same level as what the camera was spitting out. By the way, what is the camera spitting out? Do I know what the camera looks like without having the mux in there? I can do that as easy as just switching back to 2, or rather 1. Let's just turn off 2. Okay. And now let's get rid of the mux. Alrighty. So look at that. Look at this. That's interesting. So I have to build up a table. Let's build up a table of things here. Okay. Let's do that. And it's probably wise to disconnect all of this. Anyway, absolutely positively sure red is that one. Okay. Absolutely positively sure black is the top one. Okay, good. And then, it's so loud. That is so loud. I may have just lost. Ow. 6, 8. I had it cupped perfectly up towards my face. Okay. Ouch. That hurt. Oh, yes. Everything's screaming at me, and the phone is screaming at me. Okay. Okay, so here's what I'm testing for. Camera selected. There it is. Camera selected. Camera. Okay, so let's quickly test camera not selected, which is what I'm doing right now. And, okay. TX is not connected. Camera is not connected. So what I'm doing right now, camera green, which goes to red, which goes to yellow, which goes there, and is also spied by yellow. Okay. So here's what camera looks like. There we go. That was weird. Okay. So 600 millivolts and 1.240. It's definitely more than 1 volt. So. What does the camera? Okay, camera on. Okay. Okay. Oh, where I just No, with the load attached. Let's do that. Okay. Say half. That begs the question, does this actually present some kind of a 75 ohm load? Okay. Okay, where'd I put that? I was just twiddling it. There it is. Okay. By the way, I just started a helicopter. I have to take a moment to go
see the helicopter. I just heard a helicopter. Hey, what if... Hey, it's working. That's probably even... I can see it. Where is it? I hear a helicopter. Okay. Just get out of the way. This is important. I have to see the helicopter. No high RSSI items, but this has been chewing. Why don't I see it? It's right there. There's a helicopter. Red Robinson. Right there. Right there. Red Robinson. And I should be seeing it. And it's not. It's not on. Not anywhere here. Dang. Why isn't the Robinson showing up? Look at that. That's working. That's flowing. Why isn't log UAT not working? Gosh, what's your deal? Okay, UAT monitor. So it crashed. The netcat capability has crashed on it. Or it's not pushing out updates. Why? And it's right there. It still is buzzing staging. Perfect source of ADSB. Oh, come on, where did you go? It's here, and I'm seeing it in the tail. So there's something wrong with this stupid thing. Not why aren't you pushing? What? Why isn't JQ? Okay, so let's quickly do it. So it was working, but now it's not. This will have to be solved later. This is super annoying. JQ has died. Or TR. What would cause it to just die? And, as usual, ADSB scope doesn't have it. But there it is. So, living in the year 2020, splitting up everything between 1090 ES and UAT 978 makes a bit of a mess. There isn't any one true unified. Oh yeah, having the frequency split up. By the way, 244RL. That's probably, who is that? I've done that one before. Submit. Isn't that out of Norwood? Let's see who that is. Yeah, I remembered that. Blue Hill Helicopters out of Norwood. Huh. Anyhow, that's disappointing that the monitor is not working, but good distracted tangent. Where was I? I was about to do another experiment. Camera connected, 75 ohm load on the output. So, well, I already know this is going to be exactly that because, yeah, see, there's, hey, what's going on here? Oh, are you getting too hot? And it's actually, this is overheating. And this might actually be
overheating and it's not happy. That is a good thing to learn or know, is that it's terribly hot. Okay. I wonder if I'm really hurting it too by having the camera lens covered, and that's making it go to highest gain possible. And going to the highest gain is probably causing the camera to use excessive heat. So I'm going to let it power off before it's so hot. Okay. And I wanted to have the black lens cap because it gives the camera's line. Oh, you know what? I disconnected it here. What am I doing? I don't know what I'm doing. I got distracted. Okay, let's reconnect things. So green is the transmitter. Radio switcher. Okay. Green. So that's to the camera. Okay. This is what had to go here. But wait, I was going to connect the camera. What am I doing? No, I'm doing no. Camera and mux is selected. 75 ohm load on the mux's output. Okay. 75 ohm load on the mux's output is what I was about to do. Okay, let's power this back on. How are you, bud? I hope you're not too hot. Okay, I'm gonna give that a moment to cool down, or not hurt it, whatever I'm doing. I'm not really quite certain. Green, red to yellow, camera 3, and red goes to yellow, and there's the ground. Yeah, red goes to yellow, yellow would go to green. Green on that wire, green on the tail of this video win. Yeah. So selected 75. I'm going for 5 hours. I need lunch desperately. Camera connected to the mux. Selected 75 ohm mux output. Okay. Channel 1, yeah, camera, yellow. Yellow goes to green, green gets camera, which is white. Have I hurt something? I haven't hurt anything, have I? There's the mux's output that I was about to short to ground through 75 ohm. But I want to make sure the camera is fine. There we go, camera's happy. So let's quickly test this while it's going. So we want to see half wave attenuation. So here we go. Okay, so it's not selected. So when the camera is not selected by the mux, nothing happens. But now that it is selected, I just flipped the lever. Aha! And it goes to that half attenuation state. Very confident in saying that's half attenuated. Okay, let's let it power down. Okay. So basically I'm showing that and let's move this out of the way because it's getting chopped. I'm proving that attenuation by half, VTX and 75 ohm load, they're basically equivalent. I'm also showing that the mux basically pipes it through with amplification or not. what I want to do is measure what is the input impedance of one of those pins. So let's go here. I hope this is visible. Let's do this, just to be thorough. There, that's very, very visible. Okay, so same pathway. What happens to an input when it is selected? That's what I want to know. So there's a signal. I'll just... And that is, I'm mixing two active devices at once, but it's in camera input, so that should be fairly... So camera 2. Blast. Don't touch that. OF. Okay, and now when it is selected, so input 2 is selected, 10 mega ohms, 10 exactly. What happens when that, okay, so right now the buffer output, what happens when, okay, I have to do the silly thing of, okay, that should be well enough connected. So what happens when we do this? Shorted, basically. And then let's select something else, then what? Wait, that's basically shorted too. Shut up. Oh, that's because I'm... Okay, let's try that. There we go. Overflow. Okay. Now I've selected it. Now what happens? Hey! Stop it. Okay. So, what happens if it's a perfect short back to ground? So, perfect short back to ground from the output. Forward channel 2. Five ohms, okay. And any other channel isn't that? Yeah, okay. Huh. Task on. Oh, come back, bad. Okay. Alrighty, and infinite. Yep. Okay. Okay. Selected. It's active. Cooled down a little bit. Ready to connect. Get that out. Put everything back the way it is supposed to be, where the VTX gets that. VTX camera is not selected. Okay. Okay, so that's in normal bounds. Okay. There's the helicopter again, but okay. So I'll take a single. It's basically the camera waveform is exactly where it's supposed to be. Okay, that's good to know. Let's let it rest. Thermal cycling, it's not very happy. Okay, here's the final one. So, camera waveform, we don't know what happens actually. I don't know what to make of all this, but okay, let's power it back up. Got a good signal. There's where it bars. Now, the final thing is to have the output also going to ground, which is basically to feed or short across these two. Can I also accomplish that somewhere else? No, I have to do it here. Okay. Not selected. And let's just kindly give channel 2 a chance. And we'll turn off 1 for now. Yeah, it attenuates by half. Okay. Meaty fingers and not being able to steer it the way I want to. Okay, yeah, so if the camera's getting this, it definitely puts it down by half. Now, what does that actually do to video quality? Here's the major question. So, let's get this screen back on. Okay, I guess I can leave that. So is that visible? Yes, it is. Okay. So now here's the big $1,000,000 question. What happens when you have a second video transmitter load? It makes it darker. That's exactly what I expected. And this is why you don't just merely pipe the output. Okay, it makes it darker. You know, I can get away with it though. It's something you can get away with, but that was weird. Why are we getting fuzzy snow? So it can deal with it. But anyhow, yeah, this is why we want a distribution amplifier. Okay. So I feel some amount of accomplishment today, but I'm also... What have I determined other than I've proved? I know more about how the mux works, or at least I know how it behaves. The camera waveform. Let's see what happens to the camera waveform. So it's already at half. Is the camera actually doing the driving, or is the mux having to drive this? So let's see what happens. Oh, yeah, it crashes the camera. It's all on the camera. I don't think this mux actually does anything other than it just is an analog switch. Okay. Let's turn that off. I just wanted to see what happens to the camera. Yeah, it seems to get quashed. Yeah. Okay, let's let everything rest. That's it for today, unless I come up with some other idea for something to test. Okay. Should have done that full screen. Oh well. So that's just about the entire set.
really harsh. There, this is something to put into Google Keep or to record somewhere better than just a haphazard. Let's just put that here in there. Okay. Testing on 28th of April. Okay. You know, all this is probably worth saving. I'm going to push that as well. And I hear airplanes. 3. Okay. Yeah, let's, hey, look, the JSON finally decided to go. Okay. Yep. Okay, let's let everything rest. And I think I might want to just go for dinner. Are we at a convenient stopping point in terms of time on the live stream? If we're not at 6 hours, we're close. 5:24 is fair. Okay. Oh. So, what are we doing? I can't do the naive approach. That is forbidden. I can't do that. That's the major critical finding from this afternoon. Okay, as I showed earlier, there's the 3D modeling of the rear hatch, the rear receiver hatch. There's crimping the new harness. And those are all things that I can probably do off camera. I have to have the distribution amplifier, which means, back to our earlier tests from today, do I have to do a level shifter? What do I do? How do you deal with the fact that the stupid device can't do rail to rail? And I have to rush another DGK order in there. There's still something I can do here while I have this apparatus set up. I can do the real deal, in which I can take, already, so 12 volts, that's making 5 volts there. 12 volts is coming from that, so I can adapt 12 volts from there to go into this thing, or vice versa. I can just I can just have this grab 12 volts off of the board. That probably makes the most sense. So this is going to plug into the battery. Let's get rid of that. Put this back in working order.
Okay, so we will have that grab 12 volts later, but let's review. So I had it in configuration, the output. So let's this is the video. And I'm going to push the video with 75 ohm falling down. That's not 75, that's 4 something. So we want to properly terminate this. The whole point of the distribution amplifier, as it's said in that paper and others, is you're basically making a gain 2 amplifier, because properly terminated transmission line is actually going to act like a perfect voltage divider for 50%. Take that off, and don't need that anymore. So even though I've just did I write that down? Where did I write down that 800 millivolt thing and a half and whatnot? There it is. No, that's not it. Where is it from earlier today? I recorded it, but I didn't write it down. This is all the Hobby King mux. Well, yeah, I was showing 1 volt. What am I trying to accomplish here? I know I'm not going to hurt anything. I'm not hurting anything by doing this. So the input. Okay, the input there. There's 75 ohms. And then we want that to be 75 ohms to ground. This is dangerous. No, let's just do it over here. Let's do this. 75 ohms to ground. Plus, there's your input. Okay. 12 volts decoupled properly. Oh, did I really just do that? Okay, I really did disconnect the 12 volt lines. Please went to pin 7. Yeah, there we go. Let's verify. Pin 7 was, I believe, here. Okay. Pin 7 is B+. Okay. Yeah, basically, this experiment is to find out if I can capacitively couple the video signal. And, so there's ground, definitely, absolutely, positively ground. Definitely a video signal, right? Because it goes here, which goes to green, which goes to white, which is output from camera. And then, how many grounds do I have? Ground here, which is ground there, which And go find. I'm killing my back by doing this. You know, I can just have black go here. So that gets ground to there. And that's to multimeter. Probes. And this black line here goes to a mux, which I'm not going to be using. Right now the mux is just in the way, and I can remove the mux from the equation. In fact, I don't need 5 volts anywhere in this. Okay. It's going to be powering off of 12. So ideally for 75 ohm output, which there's our output. Okay, let's just go study that. Where did that go? Yeah, 75 ohm output to the video transmitter. Okay. Yeah, this is really quite simple. Yellow. Okay. And then this is going to be the output. And you can just do this. Let's just have it jog off like that. Oh, wait, but I have to. Well, yeah, I can have it jog off because that's going to that ground can just not be connected since the oscilloscope is actually not isolated outputs anything. That's fine. Ground. There, which goes to yellow, which goes to the transmitter. So it's real. 75 ohms. This is the circuit I will be doing. Goes to the real transmitter, the real camera, it pipes in there, and is actually being sampled. It's actually going there, which actually has a 75 ohm pull down, which actually goes to the input there. So that there, and that doesn't go anywhere, but it's fine. Okay. Is there any way 12 volts is going to be injected on this thing? No, there shouldn't, right? Are you certain about that, Steve? There's no way 12 volts is going to be injected. If there is, it's going to go through a 75 ohm resistor. But yes, this is somewhat scary. So let's just have this 75 ohm resistor drop to ground. Let's not actually. Otherwise, the inputs of this device, the inputs can possibly have 12 volts interact with them, except through the feedback resistor. So, but that is not going to happen. It's totally isolated from the input. That has, okay. So let's Actually, I'll just take advantage of that one there. To there. Which is ground there. Okay. So I do want to still have the probe participate in this, which means that one works. Okay. So 75 to ground, and I can see. Okay. Let's see what happens. And this is going to be a direct connection with there. So this guy is to power the whole thing. So I like this better. Let's use you for power. By the way, I'm not exactly protecting this. This is exposed to 12 volts. Shame on me. Normally I would cover this with tape, and I really should cover this with tape, actually. There's 12 volts. As long as that doesn't... Okay. And then not wanting to... let's just do this. Plane instead. Let's try. Is that yellow really good? There we go. That's good yellow. That can nicely sample from the shorted ground 75 ohms. The only defect is that ground isn't exactly bonded. It doesn't matter, that ground doesn't go anywhere. Okay. Let's do this. So what's going to happen when I turn this on? I'm going to have a video transmitter turn on. I'm going to have an output that isn't going to go anywhere dangerous. Actually, it is going to go somewhere dangerous, and I don't want to sample that. Or rather, I don't want to have that. So that way, we can do this. That will not participate now. It's not participating. Okay, there. So it's only a camera output, which goes into this amazing mess to here. Okay, let's do this. Cameras are rolling, and let's give myself a larger view on this one. Let's do this. And do I want to see what's going on with blue? Yes, I do. I want to see yellow first. Okay. So, something's not happy. Did I? What was the mode? So microsecond. Let's try this again. There we go. And if I take out the 75 ohm mode. Whoa. Okay. I'd have probably tried something because that was going well above. Wait a second. How long has that been 1 volt division versus not? Okay, is that in the normal bounds? Great, half attenuated versus... I had to just realize that I had one of these off. No, it doesn't matter because the measures are still showing. What was the measure for? Where are the cursors? Cursors were always for channel 1. And it's working correctly. Let's go to channel 2. There we go, that's happier. It's much happier. Okay. Do a single run. Okay. So what's on the output? The output's a complete mess. Now I wanted to know what happens if you capacitively couple it. So while it's live, while it's going, so capacitively coupling it doesn't. And I probably should give this a good reboot. It's probably getting very hot, which it is. Okay, there it is. And that's trigger level. Oh wait, 660. That's where I want it to be hanging out. Super confusion. Okay. What happens if I just repower this thing? I'm so tired right now. Seeing the 500 millivolt division versus 1 millivolt or 1 volt division on the O-scope there, realizing that the entire past set of tests were probably off by 2. Everything in this past week has been nothing but off by 2 errors, off by a factor of 2 or half. Gosh, okay. I'm tired. I skipped lunch. Let's see here. I really should just kept the stream at this point. Doing the streams, I'm wondering if this is just prolonging and making my experience longer than it needs to be. It's a way to focus myself, but I'm not getting much done. Okay. This is basically what it expects is 75 ohm termination. Just like that. And now the cursors are where they're supposed to be. What happens when you... Okay.
50 volts and 300 volts. Okay. What about the 1240 thing that I had? I actually wrote this down, right? I actually wrote it down. Selected, form, and then selected no load, and then selected I have. Yep, and turn that off. Everything's off, right? Yes. Oh. So let's build that up. We're going to build this thing up, but I need to add a shifting ability, so this is a virtual ground instead of actual ground. I need to make that be 6 volts. So I'm just going to push that to the other view, and let's build this thing. Okay. This is where I have to have some kind of resistive divider. And then let's not the ground. Wait, what? I said use the ground. Come on then. Okay. So I'm going to have that there. And then our generator. One terminal AC source, which I'm going to have terminated with resistor. So that's 75. Does that give me okay, so 1 volt, which is that peak to peak, or is that half wave? Now, what I have to do is I have to figure out how big these resistors are and how it affects this, which also has its feedback resistor. Okay, and then we don't care about the output. We just trust that it drives. So, I'll push it in. I don't think this would all fit. This needs to and ground. So this is what we're dealing with, and we have to give this guy, which whatever. Inputs, one terminal, 12 volt source. 12 volts. Okay, normally it would be attached to ground. So, okay.
So let's do that case of it being attached to ground. And we want to view and scope. And actually, I don't want to just view and scope, so remove scope. I wanted to watch what happens here. It doesn't even matter having 75, whatever. I can just delete that. Point is you have an input. So let's view that in scope and view that in scope. And I want to combine the scopes so we can see them both. So highlighted in blue, and this is a gain equals to amplifier. And the reason being is that's going to go to a 75. Okay, I said I didn't care about it, but let's put in our 75 ohm resistor, 75 ohm cable, which is 75 ohms of impedance, not DC resistance. So therefore, that's implied, but otherwise, there's that, and then ground here. Well, no, let's do that. So here's this side, here's the implied cable, and then here is the unit on the other end that is going to do the receiving. And is that correct? Did I really grab the correct one? I did. Okay. And there's that. So reset. So it's basically following. You have the source. Well, set 112 volts get on there. And that's ground. Wait, ground? Yeah, ground. There. Okay. Did I miss something? Why is this actually a little bit higher? Did I miss something? Can that be 150? That's... Please don't show current. What are you doing? What the heck is this thing doing? Remove. Alright, I don't need this. View and scope. View and scope. Combined. Why do I have multiple waveforms? Properties. I really don't want you to show current. Please don't show current. I don't need current. Reset. So that should be voltage and current. So it's now sagging slightly below. But if I put that to 75, it should be perfectly on top, which it is. They are perfectly on top of each other now. This is how a transmission buffer amplifier works. By the way, am I doing full screen? Yep, I am. Okay. And is there a handy point for me to... I'm almost on 6 hours. I'm going to, as usual, cut it off at the hour mark. So basically, well, first of all, the point of the simulation is what happens if you want to have this reference be something else. So I'd like to reference a so that reference is going to become something different. Right. So I guess I have to do an inverting amplifier with a in reality, I want to do this. I would actually do another amp. Nuts. I should have just gotten a bunch of general purpose op amps in my Digi order. let's do a follower configuration, which I believe means you have positive feedback, folding back, and we don't care about this, and we're just going to set you to be our 6-volt reference. So 6 volts, which is just the same as, okay, edit, show voltage, yeah, 6 volts. Can't have that, can we? In reality, this thing is writing at, what are you actually doing? I want to add an offset voltage. So 1 volt, is that what we do for the offset thingy? Yeah, there we go. And reset. So that's more like our NTSC signal. It goes between 1, well actually it shows 2 volts here, whatever, close enough, 0 to 2 volts. And now we have this guy. Did I do something wrong? Negative feedback. 2 sides of this, yes. No, I shouldn't shake the window or else Windows is going to think I'm trying to get its attention. You know what? I'm so tired right now, I just have to look up. I've forgotten how to do an inverting op amp. And, okay, so the input, and that goes through the feedback resistor, and your reference is on that side. So yeah, it's just flipping things around. That's all it is. Okay. So let's take that. There's this. There's that. Pump that in as your reference. And there. Now what do I do? What have I done now? So in the inverting case, okay. How do you level shift? I know how to do this. I've done this before in the past, but I'm rusty. I mean, you can't level shift that unless you have another amplifier. You want to right here. You know, this had an offset of 6 volts. Then things are peachy. Except I missed something. Oh, because it's 5 to 6, 5 to 6. That's really screwed up. maximum voltage is 1. So wait, if you do 0 offset. What? Oh, my mind is fried right now. Okay, offset of 5. What's 5? What have I done? Oh, because it's 2 volts. Because 1 means it's actually going to give. Okay. So that means if I put you at 6, that means you should go under between 5 and 7, right? I should go from 5 to 7. 5 to 7. Okay, good. 5 to 7. And this represents the 6, which is the ground, virtual ground. It's making 6. And that's falling. And what am I doing wrong? I'm not doing anything wrong. I'm doing this correctly. 2 to 4. Because it would normally be from 1 to 2. No, 2 to 4. I did something wrong. My brain is mush. Okay, the stream is over. I am so out of it right now. Okay. But I'm burning. Fire. Amplifier, non-amplifier. Didn't I do that configuration? Yeah, you have your reference. There's your input versus the inverting, which is really just that upside down, where you've taken your reference and your signal. So now I'm in another G order. You know what? The AD part, the AD locast, is that it? I think that's the other one I ordered, isn't it? This is one. Let's go get it out. Let's go get it out of its packaging. Or go look at the package. That's right, I already cycled it down. It's the 8055A. Yep, 8055. Alrighty, so these. I was brain dead when I ordered this and when I ordered the TI part. I wasn't paying attention, or rather, it's just because I don't do this often enough. This is good practice. Characteristics, swing voltage. Is this one rail to rail? Let's read.
think I understand what the 150 ohm mode means. It's because you're expecting -5, +5. I wasn't really paying attention to the requirements on this. So single side, oh wait, single load. How many singles are there? Single-ended differential, single load, single-sided. Let's look for side. Southern side. Side 2 driven, side 1 driven. Okay. Let's go to the original DigiKey. 805. Yeah, DigiKey and the cataloging person. Amplifier type. And output type doesn't say anything about rail to rail. Can't use it for single-sided. Even though you'd have 8 volts to 12 volts. What it really means is this is designed for -5 to +5 in a video signal. Okay, the stream's over.